Namaskar, good morning, good day. This is Suraj Singh calling from Bharat, India. To all my friends, Assalamu alaikum wa rahmatullahi wa barakatuh, Sat Sri Akal, Vanakkam, Namaskaram. And this is 5th of August 5th, 2020. Another serious day of life for whole world, as the world is small now because Corona has made it very small, and no way out, no way in. We can say we have to tolerate everything. I'm sorry, I don't know what's happened to this screen. It's very small now. This is certification. As usual, I show for reference. I show only for reference about what is happening in the world. Well, gentlemen, gentle people, I am here to interact with you and hope you are all receptive of what I say. This is small people with normal life, no show off in this. Just I remember with this my past life. It is a history of world that you had to write with hand. For those particularly, history should move. History should tell what we are, what we were. And this is, this contains all talks what we want to make, what I want to make in this. This is, and also I'm really looking because this is a 10-minute video, so I don't want to leave something undone, and people should not think what I'm doing should be clear to everybody. What I'm talking about is very important one. What I'm talking about, and that's what we say. Some references I'm giving as it happens, as you all I'm starting with this file. I have not seen any major changes in this file, but this just works. I used to talk something about COVID every day if possible, and whether it's virus or God's act, engineering, and what is engineering management, and what is engineering systems changes, and what is organization, and what is challenge, and what is human thinking. I stop at human thinking always. Human thinking, then only resorts, and general comes from specifications and total systems, quality, structure, and soil investigation, etc. We talk that way really. Soil reports, FIDIC 2017, red and silver book and yellow book, all white, whatever we can, and same way we go down, just for your reference. Same. I don't know why it was very small screen by human thinking, very important for me, for you, for everybody, because well, gentlemen, this is all about, I have not made any changes to this for long, no problem at all, no. I'll start with something, just for reminder, my profession is civil engineering, just for information, as I usually intimate, but for those maybe who are new, who may not know, who joined recently, who view this video means in coming time, I'm like to say I'm civil engineer, and my small identity or brief identity is that I am 66 running now. I'm 1955 born. I passed my first diploma. First, you can say 3 years civil engineering diploma in 1974. Then I joined some assignment and also continued to study. And I qualified. I passed my section A and section B of Institution of Engineers India. Section A I passed in 1978 and section B in 1980. And then I did not study any further because of circumstances that I had to leave this country, go abroad, overseas, and I worked there many times, came back and worked there. And particularly I was involved in site works, on site activities, so chances of joining education. Though I also wanted to pass further studies for status purpose or knowledge purpose, but I could not do that, could not afford that. Of course, I feel in for that, but it will make a difference because now I feel what I learned from sites, I learned from experiences far better than book knowledge. Book knowledge is that's registered in books or author, but field knowledge is very important. Field knowledge which actually is learned by working. It's not simply by guidance or by referring to books. And we are refer to walks, we refer to sites, actual activities in field, which is much more in demand. And I learned from that. I could not learn that much when I was here. I worked in this country for about 6 years, and of course stayed with the State Department. I compare that learning and what I learned in field, this vast gap which required to be filled. Well, I can't do that, and it's not individual work that we can solve this problem. In mass country like ours, means 135 crore masses belong to this country. Because I am from engineering branch, engineering field, profession of engineering, we call it profession of engineering, and we should understand profession, and also we should understand engineering first. Only then we can say we can understand something. I say I'm an engineer, I'm a professional engineer, or I am a chartered engineer, or I'm this engineer and that engineer. It's okay, fine. As far as term or designation is related to, it's fine. But what is engineering? That always remains a question mark. I don't want to go to definition of what law states or what institutions state. I have different philosophical as an individual. Means, after all, what is engineering? Can someone define engineering? Can I define engineering? Can you define engineering? And if suppose many people define engineering, shall it be same definition, or it will be unique by everybody? That point comes to my mind. Really, it's very important point. Define engineering, because if I ask some student, can you define engineering? You are doing engineering. And if I ask some engineer itself, can you define engineering? Or a professor, can you define engineering? Or a professional, can you define engineering? I think I'll get all different answers. Because there is no certain answer to this. For professional, it's just to do job and get money and deliver something and get money and express that. Yeah, that's fine. For some student, maybe a degree course or a diploma course or possibly supposed to pass that and get some job. That's engineering. I mean, job is end for student, means and if you ask some general public or a professor will use some confusing answers, maybe some answers that neither relate to education nor relate to profession or actual work. So you can say everybody shall answer differently, and I will try this. Means I will not go to charter what charter says, or I will not say what actually profession says, because one engineering is professional explanation. Another engineering real life. Means what is real life? Because I'm talking about engineering management. Engineering management means it is management of engineering or engineering management, means I can't understand that. If I'm talking engineering management, if I compare to syllabus, it's nothing more than what we used to do in field. Means we used to do something in field, and that if that all gross activities are included in some subject, then that's the fine. engineering management. I'm not asking that one, what actually engineering is. I raise a question to myself also many times. Means just to having a job, and before that having some educational qualification, and then whole life working on that job and earning money and then retire. Is that engineering, or some mission is engineering, or actually what is engineering? I have spent my life, I always thought what I am doing, I have to serve, I have to find some job every time. I think I worked in more than 11 organizations throughout my career, and I could not understand actually till now what is engineering. I worked on many projects, I delivered many structures, and I worked in technicalities, I worked in contracts, I worked in designs, I worked in planning, I worked without computers and with computers. I don't know how many cubic meter of concrete I was involved with, whole life has gone, but I could not understand till now what is engineering. You may say what this person is talking, or you may talk this person is really was a psycho. Yes, thank you very much if you think that way. I am a psycho, I can say. I am. Because engineering relates to psycho of the person. Engineers relate to that. Engineer or engineering are not mutually explanatory. Engineering, and engineer is a title, you can say. It's a professional title, or some responsibility owning title, some obligation and responsibility and accountability owning title. That is engineer. But engineering is not a title. It's vast world engineering. It comes from God itself, engineering. Because God also engineered something. When you say engineer, means it's a verb or it's an adjective of what actually it is. We must think of. Thinking is very important. And basis of engineering is thinking. Actually, basis of every activity of life is thinking. But basis of engineering is very much thinking, because engineering is not rigid, engineering is flexible. Engineering has got, an approach where all forces are digested in, all attacks are digested in. Engineering receives all attacks and refines those attacks so that these are digestible, condensable. Engineering is not just education, it's not just field. Engineering is like, it's like, as you say, I am religious, I am Hindu religion, Christian religious, then you say that, some people, you say you are professing Islam, you are professing Dharma, you are professing Christian, like that. Why you call profession there? Profession of religion, profession of faith, you say that. Why we call profession there? What's profession there? There is no profession. You are not doing anything for someone, you are not doing anything, but you say profession of religion. I profess, by faith I profess this religion. I say that. So why do we call profession in what? And Hindi we call it vritti. Vrit means a circle. Circle, you understand vrit. In Hindi we call vrit or Sanskrit, and in English it's called a circle. Which circle is this? This means there may be many circles, and engineering is one of them, medical is one of them, other like that, right? Life has got many circles. Or spheres, if you say in 3D, maybe spheres. So I am from professional engineering sphere. You can say that. So I am a professional sphere. I am a part of that. Even then engineering is unclear. Medical is clear. You have methods and you have to treat patient. Accountancy is clear. You have methods and you have to ensure audit, and also other callings. I should not call them profession everywhere, because law and justice, and you can say many other such fields which call themselves profession. Okay, you call them profession. It doesn't make a difference. But question is, we don't call engineering as a profession, or we call it a profession. Are you doing profession in this? What's profession? You are you know, then we should also ask another question: what is difference between engineering and economics? Are they correlated or they are different? Do they belong to same family or they belong to different families? These points engineering must be clear with. When one student joins engineering institution, that is joins not because that is to understand engineering, that joins because that has to pass that, and after that some higher education, and then to either get some job or then change engineering and go to management or organizational work or to some administrative work. This is basics, means there is no consideration of delivering development service to public. And this is not only for engineering, this is for everyone. All other entries to higher education, entrance to higher education, they consider, yes, package. Shall package overrule engineering, or engineering has to create package? You understand what I am saying? Engineering has to create package, or package has to overrule engineering. Every student must understand this point and answer to itself this point. After all, it's question of whole life. Whole life you have to work as an engineer, but you don't understand engineer, so how shall you work? If you think only job is work, no, job is not work. What actually engineering is, I understand differently. Maybe you understand otherwise. First of all, term of engineer, name or this word itself says that you cannot do anything, use your mind first. Genius. Genius means engineer. I-N-A-N-G-I-R, or I-N-G-I-N-E-R, both are same. E-N or I-N are same in English. In or E-N, both are same. One is English word, one is another word. Leave that country's name. Giant, engine. It relates to mind, thinking. It relates to power of mind, power of thinking. How much you can think, it depends upon that. Higher level of thinking leads to a level where you can be named genius. This means this word is genius. The question is, a student should ask, is he so? Is he or she genius? And if you think you are genius, then you should be happy. Because you are going to be a genius professional in life. Engineering is something you think with high power. You think plus think plus think plus think plus think. As many number of times you think, you find different answers. You think first, you get some answer. Answer to what? I did not tell you. Answer to your problem. Answer to your problem, you get that. So what is that problem? Whatever problem is there, whatever problem of society, problem of individual, in relation to your life, or otherwise in relation to otherwise. Your job is engineering. If you are a civil engineer, you are related to whole society, directly and indirectly both. You are required to learn many subjects to do your job. That is relational engineering, that is referral engineering. I would not call it engineering that you think. That is, relative basis. You have to do that to become an operational engineer. Operational means one who can operate engineering, or eventual engineer you can say. Forget professional and forget, because those are legal terms. I am not going to that. I am going to philosophical terms of engineering. Engineering means one should be capable to think. That is engineering. And if you are not capable to think, you are just capable to do something without application of mind, then you are not doing your job. Only profession that requires very serious thinking in every act or profession is engineering. You cannot follow alone even if you are fresh or even if you are a student. Okay, you have to pass examination, I understand. Passing examination is one part. You have to move in two boards in your education. One is criteria to pass examination, that is your requirement. You cannot go against that. But there is another board also that tells you you have to learn something. Learn something. It is not necessary that you pass some degree and you think you can solve problem. Passing degree is not learning. Learning is different. Your passing degree stops when you come out of university. Degree or post degree or doctorate degree, you can pass them in limited time. There is no obstruction to that. If you have patience to work, patient to write, patient to think, you can pass in some, you can say, formal design of that program. But you have to raise a question to yourself. Everybody, myself included, did I really learn? Did I really learn what I have to do? That is one point of view. Passing is another point of view. Passing can consider you for some application of job, but learning is to run that job and every job that you will get, or even if you do your own practice. Engineering is actually meant to do self-practice. That is really basis of engineering. But now there are so many fields of engineering that practice is not possible. In fact, if you see history of engineering, you will find three basics engineering, to be very frank. Three basics engineering. Number one is civil, number two is mechanical, and number three is electrical, and there is no other engineering in fact. That's a fact of life. Other engineering are relative, not fundamentals, not basics. Even architecture is not basics. That is something else. That is related to civil engineering. If there is no civil engineering, there is no architecture. Electrical engineering is also basics because it gives you basic requirement. Same thing mechanical. This is also fundamental because without this you can't do anything. So these three are a triangle of engineering. I can say, just like a management will say, these 3 points: time, cost and quality. So this is a triangle. Electromechanical and civil. This is a very strong triangle. This supports all of us. When these three people work together and others jump in, they find space for themselves. And if these three people don't work, others come in, they won't find even entry. Just think of that. Experience that. There is IT engineering, electronics engineering, or aerospace engineering, or there will be many more. Mining and environment and this and that, all that. Those are all generated one for expansion of family, extended family of engineering. But prime family is when you have to start something, you want to think something, you have money what to do, desert can be converted, forest can be converted to cities. You can say, I have to convert this desert to an industrial city or a residential city or something else, wherever, whatever, water resources. What you want? What do you think? Who comes into picture first? Who comes into picture? A person who goes there to see that area, to find some area for something. and that area is rough, wood, forest, desert, where you don't even find to stay somewhere. But you have to do that. You have to start that. So that exclusive grain project, exclusive grain, that requires your tempo, your temperature of your body and your mind to start something from inexistence of something. Yes, there's earth surface, there's ground. Just think of that stage. When some goes barehanded, just to think I have to find and get this land. Oh, this possible. Who shall go there? Only you can say, unknown person would go there. And who is that unknown person? That unknown person is civil engineer. Civil engineer who should smell hydrogen sulfide, who should smell carbon dioxide, who should smell gases flying over industrial areas, who should be able to respect dirt and scratch and you can say garbage, who should be used to all that, who should be able to stand in sun for hours together, who should be strong enough to digest hunger or thirst for a couple of hours. Who is that? Civil engineer. Why we call civil engineer? Because this is real civil. This is a real public who gives to public something. It is super public. Civil is super public. Civil rights. Civil rights, public rights, or fundamental rights, civil rights, or natural right, you can say. Because civil is natural, human is natural. So your job is natural. Is it or not? Yes, it's right. Your personality is like a worker, only worker. When you are there in such adverse environment, adverse weather condition, and you sometimes are in 45 degrees, sometimes in 50 degrees, sometimes in 12 degrees. It depends which location you are. You may be in Baghdad, you may be in Libya, you may be in Sahara, you may be anywhere, somewhere where weather is not comfortable for you, or it may be comfortable. It depends upon situation, circumstances. Civil engineer means an engineer who actually does not aspire anything except accepts worship of work. I should call this worship. You are an only representative of that power. That power, I am not talking spiritually, I am talking practically. You are first person who is going to use God-given resources. You are first person, not second person. Others are second and third and fourth. Engineering management has to be understood in its spiritual power. That's why I'm asking the question. What is the difference between engineering and economics? It's not I'm talking macroeconomics. No, I'm not talking. I'm talking more than above the macroeconomics. Macroeconomics is economic of your whole nation or whole world. I am talking economy, real economy. We have to ask question, what is economy? I am not studying economics, I am studying engineering. How can I answer this? Yes, you are right. You can't answer that because you are not studying economics, you are studying natural economics. Natural economics. They are all economists who undertake macroeconomics, who amend that, who modify that, who understand that. They are only economists, but you are not economics. You are user of resources, user of sources, natural sources. No natural source means you cannot do anything. It is natural source that makes you engineering professional. It's not education. No, education is second. Education is second. Education is never born in university. It's never born in colleges. Education is created in life. In life. There were projects long before. We have seen many projects which are now gone, lost. Why do we do archaeological excavations? Because in those days also we find many cities, or we have found this. This means people used to build that time also. When there was no engineering. Engineering is a referred subject, it's a referred profession. It's not original profession. Original profession is here. This is engineering. God is biggest engineer, do you know? Have you ever thought of this? God is everyone, but I am talking of engineering. God is a doctor also. God is a calculator also. God has got every profession. But particularly, first one God created as engineering. We talk of construction, we talk of designs, we talk of everything like that. For very, very small structures. We make big, all that, right? I am going to make this building, this bridge, this bridge, the flyover, biggest one, the longest one. Oh, boasting a lot. Oh, longest bridge in the world, highest dam in the world. Oh, my building, highest one. This and that. Boast a lot. Why? Why? Can you answer this question? Why do you compare first of all? Oh, Burj Tower is this, and Qutub Minar is this, and Vikas Minar is this. Why? This is the longest platform of world. Whom you are telling? Whom you are telling? You want a small guardhouse, you want foundation of that. You want a small building, you want the complete design of that. You want very big cities because you want town planning of that, and this planning and that planning and that. So I'm going to propose town plan, and thousands of professionals remain busy there, so that lakhs and lakhs of people can stay there. Well, that's fine. But is that profession only? Is profession design or profession planning or profession construction? What's profession? Basically, we have to analyze ourselves. That's why I have to say two boats. One boat you use for educational purpose just to pass through. This will be another boat which is for you. That is for public. That certificate you get from university is not for you. It's for public notification. This person, this will now be addressed to you. Remember, just try to understand what I'm saying. That certificate you receive after passing your degree or post or whatever shall not be addressed to you. It shall be addressed to unknown. Right? This degree is conferred onto this person. This is only to you. No, it's to this person of this address or whatever, father and son. There's this notification, gadget of that university. This university has charter of that, has legal right of that. University itself is a chartered body. Chartered in the sense, not formal charter here is UAK. Charter means charter of rights, charter of power. This institution is empowered to issue such certificates to students. That's one. But there is another one. You get this certificate, that's fine. That's your basic requirement. This is a measurement of your competency. Certificate is nothing. It's a measurement of your competency. What is your value? The value, there are so many kinds of vegetables in the market. It's quality of that. It's performance of that. It's how many days old, this is fresh or not. Like that, you select price, you elect price and decide, this better, this not better, this is good for me, this will stay for me. Like that is engineer. Your second vote is most important than your passing vote. You have to move together in both votes. I mean to say, not at same time, some keeping like you are in the daytime in your college, university, your teacher teaching you. You have to learn that. But your teacher cannot teach you everything, remember. Teacher is also bound by time, bound by syllabus. Teacher is not unlimited. Teacher can only guide you. It doesn't matter. If you learn about what's in syllabus, I know you don't have that time in your 5 or 4 year syllabus, but you see, if you don't learn it, Again I am saying learn and pass. It's two different. Passing is not actually learning. Passing is a compulsion. You have to pass. But learning is not compulsion. That is your option. Name itself is learn. L is added here. Learn. Learning is unlimited. Passing is limited. Again I say, you have to pass this in 3 or 4 or 5 or 6 years or 7 years. All these degrees come in there. But learning is lifelong. Real learning, not simply statement of learning. Oh, I have learned this, I have learned. No, you have not learned anything. You have not learned anything. Because you never studied further. Study doesn't mean university study. No, not formal study. Extensive study, unlimited study, broad study. You move anywhere you study. Once you are an engineer by qualification, you think you cannot read books of higher education? You can read. When you read thousands of drawings in your life, can you read those drawings here in university? You cannot. Because this is not actual requirement. The university can't do that. It's not possible. But in failed, if you are an engineer, what shall you do? How many engineers know this? They themselves think that they are bound by time, they are bound by this designation or professional title here, and they have bound by this project, and they are getting this much, and they have to do this. If you keep that scale, then you are a skilled person. You are a person having valuation of that level. And if you are a broad-minded person, if you have vistas which can't be seen narrowly, which are very extensive vistas, those vistas can take you to horizon and to mirage. You can't catch them. Move and move and move. Horizon you can't catch, mirage you can't catch. That is what learning is about. Don't measure learning with degrees. Give degrees, respect degrees, have degrees, that is required, but don't depend upon them. Just I was telling you about engineering God. What God is? Is engineer. What? How engineer? You can't say God is engineer. Yes, God is engineer. It's not by degree or diploma, it's by work. When you construct some small structure, you design for that, right? How do you design? You say, these are my subjects, I use this formula, this process and design. I use applied mechanics, or I use theory of structure, I use structural design, and we say, this I have done. And with very high pride level, I say, I have done this. Best design it is. Yes, your design is best. Your design is best, among very, very best. Okay, congratulations. You should have that blessings, that wishes with you. Congratulations yourself and congratulations by all. You can self-congratulate that because you feel pleasure. The question is not that. You are an engineer or a student. You know what is dynamic forces, what is static forces, what is equilibrium, everything you know. I'm not going to have interest in that. You know all that. You are well qualified. Your professors have taught you everything. Your books have taught you. But just think of, you are given a project of construct solar system. Don't be shocked. I'm not going to give that. But just think of, you are given a task to construct solar system. Construct solar system. Can you construct? Because I'm a civil engineer, how can I do that? Yes, that's why I'm asking you. You are a civil engineer. I ask you, construct solar system. You would say, this person is, I should say, what I don't know what you say. This scientific person, what nonsense is asking this? No. Again, I say my question is, construct solar system. Terrible person. He has spoken and doesn't understand. He is asking again and again same thing. Yes, I say construct solar system. Think, did God do that? Did God do that? Because there is existing solar system. This means somebody must have done that. Is there any mechanical engineer for this thing? Or actually for this thing? So, no. Only civil engineer. You see, all members planets of this system, you will not find any structural basis on this, any structural design or structural system for this, but this system is perfectly working. This is universally working, and it's been working, I don't know for how many crores years, I don't know, because it's unknown, but it is working. Do you agree or not? Many of you may not be knowing what I am talking about. I am talking of solar mandala. I am talking a part of universe where sun is considered central planet. You are an engineer. You know what forces are. You know centrifugal force, centripetal force, other magnetic forces, all forces you know. You have well understand physics and atomic physics and chemical physics, all that you know. You know statistics, you know dynamic, static force, this force and that, all you know. You must be know because you are an engineering student or qualified engineer. That is your job, you must know. If you don't know, then you can't pass, simple. You must know fluid mechanics, you must know geology, you must know everything according to earth sciences, you know that. What about that science? This is not my discipline, this is space. This is a space, of course, but you are also living in space. You don't be surprised, I am telling you a fact. You are also living in space. Only a difference of 20 kilometers. You are only 20 kilometers away from space, not more than that. Overlapping space starts from a distance of 20 kilometers from earth level or sea level or surface level. Don't be surprised. I can walk 20 kilometers to reach there if I am allowed. But I can't walk this distance, not walkable. This distance is flyable. If you can fly, you go there. Only 20 or 30 kilometers. You don't have moved to thousands of kilometers to enter space. So why we make such hue and cry of space? Oh, we have sent this rocket or this, we have launched this orbit. You see, we make hue and cry all over her. Beauty of nature, beauty of God. Think of your God, how will you design that? This is basis of civil engineering, I am telling you. This is basis of civil engineering. Civil engineering exists because of this. There is a complete equilibrium, dynamic equilibrium. There is no force left which do not involve itself in this system. Varying sizes of planets, varying speeds, perpetual speed and orbital speed, varying distances, locations, sea distance. These are working. These haven't any structure with them, no structural anatomy with them, no structure with them. Nobody knows composition of this, but they are there. This means there is some science. Without science, you cannot do it. Without engineering, you cannot do it. This means that power, so-called God, must have done something. Who will teach you that? This is not your syllabus. It doesn't mean if it's not your syllabus, you can't understand this. How to go to toilet and use, is this in your syllabus? How to eat food, is this syllabus? How to go and walk on road is your syllabus? No, it's not a syllabus. But you do all. This means syllabus is not for everything. It's for something. And your life is different. If you are asked to design sun, can you design sun? You cannot design sun. Because you have the capacity. But it is there. 13 lakh kilometers is diameter of sun. Don't be surprised. 1.3 million kilometer diameter is object sun. And it is working without any column, without any beam, without any software, analysis, it is working. Same thing valid for all planets working. You are sitting on this planet, this is Earth, it is working. You think of now as engineer how it is working. This is your job to think. This is not others' job. You are civil engineer, you are mathematician, you understand dynamic forces, you understand static equilibrium, you understand dynamic, you understand everything as far as engineering is to an extent is considered. So it's also a part of your job. First you understand how it is done, then it will be very easy for you to understand what is done. When I say Earth, this means if you come out of Earth, I have been in space, right? If I say I am in Earth, I am on Earth or in Earth. I am saying in Earth because there is a reason for that. I can also say on Earth. There is nothing wrong as far as English is concerned, but there is a technical difference. If I say I am in Earth, I am within Earth because I am in air, and air is a part of Earth. Yes, if I say I am on lithosphere, that's different. You must have studied geology, have you? And if not, then you study this after you pass examination. That's very important. Don't miss this subject, geology. This is first engineering subject actually. It should be first subject which we don't understand. Why it's not there? It's a part of engineering syllabus. If you don't understand geology or applied geology, at least if not complete geology, then we cannot say we understand engineering. You can't. Just like if I say soil, mitti, rock. If you don't understand soil, you cannot understand building and foundations. Forget it. You can never become an engineer if you don't understand soil. This is also a fundamental requirement, but we don't care. We just care only to pass examination. Now, I was talking of planetary system, though I'm not just trying to open your eyes. This is civil engineering actually. This is mathematics and civil engineering. This is not space engineering. Space engineering is to go and do in that is space engineering, but construction of solar system is civil engineering, which we can't understand. You take members, when you design a structure, you analyze, right? You analyze everything. You analyze each whole, you analyze, and each part you analyze, each member you analyze, and you say, I have analyzed and this is my design. Think of 15 crore kilometer location of Sun from here, 76 crore kilometer location of Jupiter from here, and like that all planets are there, and they're all working. They never stop. This means there is perfect equilibrium. Internal as well as external equilibrium. Right? There are many unknown forces surrounding those planets, but they keep working. They encounter those forces successfully. They keep working. How? Don't you take it into your consideration? There may be thunderstorm, there may be fire, there may be anything, but these never change their route. This means there is some perfect application. Why don't we do that? When these can be designed without structure, why don't you understand that? Yes, we have to design, I know. I am not denying the fact that structure is required. These are also structured one. I cannot say these are not structured one. This is having an internal structure. These are having internal structures, not external structures. And that structure is unknown to us. Another point is, if we say these are by chance working on themselves and they are balancing themselves, no, they are not balancing themselves. If they balance themselves, they can fall. Earth should fall then. Jupiter should fall then. Fall or go upwards, wherever. But they are not doing that. If you just a little earthquake and your building collapses, little high wind pressure and your building collapses, why collapses? So Earth should also collapse, Jupiter may also collapse then, but no, they did not for how many, since they were built, since they were produced, This means there must be done some high degree of work done of mathematics, or generation of mathematics, or birth of mathematics, or birth of negative positive powers, all that. But remember, these are all busy objects. These are not sleeping objects. People are sleeping, we are sleeping. These are not sleeping. These keep on moving. And if these sleep, means everything shall collapse. Whole system shall collapse if they sleep. They can never sleep. They can't stay whole journey just for 1 second. They can't hold their journey. Earth is never stationary. Earth is never located in 1, 2 or 3 coordinates x, y, and z. It keeps on moving. All planets around sun keeps on moving, and sun itself does it works whatever it's doing. You may not understand this immediately, but fact is that Earth, there are 2 speeds Earth moves with. You know that. You must have studied this. Maybe second speed you may not be, but first speed you say this flight is international, it flies at a speed of 900 kilometers per hour at a height of 10 kilometers, and this is my rocket, and this is my launch, and this and that, all we boast about. This is Concorde flying at a speed of 1600, and this is our supersonic, this flying the speed of this. Okay, you boast that. But think of Earth. Apply mathematics, find out. I did that approximately. Earth is moving with 2 speeds, we know. One speed is perpetual on its axis, other speed is around sun. You calculate, it's not big difficult, it just take 10 minutes to calculate that, even less. And I declare by my approximation that Earth moves on its axis speed of 1600 km an hour, 1600 km each hour. And it orbits a speed of 1.25 lakh kilometer, 125,000 km an hour. You may not imagine that speed, 125,000 km an hour. That speed with which, if you send these rockets, your orbits, satellites to Mars or to Summer, this speed is about that. Now UAE released one same space rocket, spaceship. It is moving with a speed of 1.25 lakh kilometer, 125,000 kilometers. You think that speed is fine? You are. All are you moving in that speed? You don't feel that. All are speed that. You don't feel that. You are in space. That's what I'm saying. You are already in space, but you are little away from space. If you could fly space, you could travel every day to space, and means I'm just going to have a walk into space, just going for an evening walk or morning walk, and just imagine that state of science, that imagination, that speculation. Or I'll take this material to space, construct there, and send it back to install here. That could be another practice. Oh, only 25 kilometers, 50 kilometers I have to move, no problem. We can send truck there, it will go there, we make a yard there, casting yard, and that will cast come back here. Can you just imagine this scene? No, you can't imagine. This is what I'm telling you. You learn engineering not to pass, but to understand. Passing is one engineering and understanding is another engineering. Well, I sometimes talk irrelevant, sorry for that, but it's important. What I say, I put in my this text of, I say this, when I say what we have to talk, I say think, T-H-I-N-K. Think, T-H-I-N-K. Again I say think. This is an only resort or only solution to all our problems. An engineer means the person who thinks. Otherwise you are not an engineer. No. You have not to interpret. You have to think. You have not to understand construction. You have to think. You have to think and change. I say change and think. Change is engineering, thinking is engineering. Only profession that depends upon thinking and changing is named engineering. No other profession does it. Even medical does not do it. Because there is no authority in medical to change it. They can think for defined procedures, but they can't define procedures based on thinking. Their definition cannot be declared. You have to declare your definition. You have to generate your definition. Therefore, engineering is unique. Don't compare it with money, how much you earn. Because you are part of universe. If you work in civil engineering particularly. Civil engineering is only a gift by God. Because he himself or she herself is civil engineer. First, there is no electrical engineer on earth except we have. Earth is illumined by one electric power station, and that is sun. How does it work? Nobody knows. How does it emit its light? Nobody knows, but it is universal power station. It enlightens, it illumines all solar system, all time. So there is no wire. There is no overhead line. Yet it is working. Electrical engineer is sun. Thermal engineer is sun. And other agencies are all earth-based. Rain, air, like that. It's completely different I am talking. Try to understand what I mean. I don't mean to discourage you. I mean to encourage you by saying you are higher level. If you think without money, and if you make your ambition is just the money, then I think you are not engineer, cannot be engineer. Only thinking application is in engineering, only thinking application. Because you think and do. Think and do. As we see in quality world, we say think, do, check, act. Or we say plan, do, check, act. Think and plan are no different. No different. There can be no plan without thinking, and there can be no thinking without plan. You have to plan and think, and you have to think and plan. Both are there. Every stage you have to think on plan also. You have started a plan, initiated this, and then you are moving from one point to other point, and third point to second point. All that you are moving. So at every point you have to stop and think and plan again for further one, and then stop and think and plan again for other one, and so on and so forth. You move on that track till you get something as result or some attainment, you can say. This applies to your education also. Don't think that your education is complete. Never think that. It's only referral. Even if you have gone through 50 books, 60 books you've gone through, it's not complete until you experience that. And experience in designs, experience in sight, experience everywhere, all these count. And engineering is therefore completely defined in different way. And you can define just in 2 words, and that is think and deliver. Do you hear what I said? I said think and deliver. This is engineering, nothing else. Don't include all those procedures that you are taught. That's for education purpose. But what do you think? If you can do that, that is engineering. Simple. Very small activity, very, very small activity. Think about that, do it. And when you say do it, means think and do. There's a long chain in this, long working and supply chain in that. You start from thinking and then you have to deliver. It's very, very long journey. It's not simple journey. So you just hold 2 ends of this beam, fixed beam. Don't pin it and don't partly fix it. Fix it fully and see the what moments come into your hands, what forces come to your hands, what shear force and what deflection comes to your hands, and see how tangential forces are to come there. So these two ends are very critical. This can collapse, this can sink, this can hog up, this can, and what happens in between these two ends is very long beam, and everywhere there is a force, and many forces are there, or all you can say, all stages of work, and these forces give you very much bending moment and shear force. That also you have to find. So you can say this do, a think and do, or think and deliver is a beam. Yes, it's a beam. It's very long beam, very long span beam. This is also fixed. You can make it pinned. You can make it whatever simply supported. You can up to you how you take it. It can tell you. So your teacher should say, is this beam our profession beam? Yes, our profession is beam. B and M. BE stands for B and AM stands for AM. We say be this. Just only fun I'm making. Engineering, don't take it very seriously. Engineering is a fun actually, and this fun is permanent. When you go to see a movie, you just enjoy for 2 to 3 hours. When you go to somewhere else for picnic or some resort, you can enjoy for 1 or 2 days or 3 days. But engineering, if you make it your destiny, make it your picnic, make it your resort, make it your life, entertainment, then engineering is for you. No, otherwise no. And if you think, no, what I'm guiding out of doing this, then you are not engineer, you are a businessman, and businessman doesn't mean engineer. Businessman cannot be engineer, and engineer can be a businessman, but a businessman cannot be an engineer. Just mind it. Keep in your mind, if you think of money, then you are spoiling your career. Money, it doesn't mean that you are an engineer. Money means your aim is very small. Very small aim. If you compare to solar system, you cannot make solar system, but God did that. Did God charge you anything? Everybody is using this solar system. Are you paying to God any lease on this? We are not paying any lease. Are we paying something to sun? We are not paying anything to sun, or air, or rain, or something. Are you paying? You are not paying anything. You are enjoying everything free of cost. This is life. For something you buy in market, you have to pay. Everything you have to pay. But to God is free, completely free. Try to understand what I say. My mind is a little crazy, I am a crazy person. Crazy in a sense, not African meaning of crazy. Crazy in a way, you have to unearth every secret. You unearth every secret. And that's what engineering is. Remember, engineering is secret, nothing else. Secret, how secret you say? It's known? No, it's not known. It's not known. What's known? Nothing is known in engineering. Very small is known. And what is known is not directly, it's copied one. In engineering, we don't know anything. When I say think and do, what do you know there? What do you know there? If I ask you, Matthew, one simple question, you are all engineering here. One simple question here is, very simple question is, you always say materials and materials and materials, and hundreds and thousands of materials we talk of every day. What do you consider about soil? Do not confuse yourself. Let me tell you one thing first. Actually, we all world people are hungry for economics. We are all hungry for economics in a way that we want our economy go up and up. This is called foolishness, I can say. Economy can neither go up, cannot come down. It cannot. This is relative cost. This is relative valuation that falls or that rises. You can ask a question here. Why? How do you say that? You are an engineer talking economics. Yes, I'm an engineer, I'm talking economics. Because economics and engineering are related. Much more related than what economists think. What resources do you use? What resources do you use? What do you use in your structures? Where it comes from? Who gives you this? Do you ever ask a question yourself? Who gives you this? You say, I bought this material and I bought that material and I use this material in this structure. Okay, you are using that material in structure. From where does this material come? You say it comes from crushers or it comes from factories. But where does it come from to these factories or to these? Again I say, it comes, you think you have no answer. You should understand why no answer. It comes from sky, you think. Does it come from sea, you think? No. Even if it comes from sea, it's a part of earth. It's earth. Whatever resources, sources, materials you use in your life, everything comes from earth. Lithosphere and earth. You may not understand it in one go because your thinking is busy somewhere else. Maybe your concentration is not what I'm talking of. You have to concentrate first. You concentrate on what I'm saying, and again I'm saying with full responsibility that it is earth. It is earth. Economy is nothing but value within earth. Tell me anything. Tell me something that comes from other than earth. Even you get crops to eat, that comes from earth. Simple. Very simple. From where does it come? Think. Again I say think. You are thinker. If you develop thinking habit, you will be best engineer in the world. Don't think formalized. No. Don't think only be formalized. Don't just apply your formula to get answer as engineering students are used to. I have this formula, I use this parameters and get answer. That's fine. For examination is okay, but not in life. Try to find results without using formula, without using something. Think of yourself, how can I do that? When we design some structure, particularly building something, I never say design column or beam first. Never, I don't believe that. First we have to create something in mind. Is that creation easy, you think? Is that imagination, you think, easy? It's imagination. You may say it is imagination. It's not reality. But I say this imagination is reality. Image. What is image? Is that real or not? When you see your own image, what is that? It's real or no? Is it not same reflection or projection in your body or face? It's same. This means it is real without your soul. It is what you are. So imagination cannot be said to be delusion. It's not delusion, I am talking imagination. Imagination is a reality because it's work of mind, and I am talking mind. Mind which engineering uses, though you may not feel that, but you are saying sometimes this person is brilliant, this is intelligent, this is a scholar. Why do you say that? How do you say that? What relation you have to got to that definition of that person you relate to? No, nothing. But you say that. I am not talking psychology. I am talking engineering. Again I am saying I'm talking engineering. You first apply engineering onto yourself. As human being, you will understand engineering. Simple. You may not understand engineering by your 35 to 40 subjects. You may not understand that. But you shall understand engineering by your own. What you are. What is your body? What is your mind? What is your understanding? What is your soul? You will understand engineering. Again I said, same two words, that think and do is engineering. Think and deliver is engineering. There is no other definition of engineering from understanding viewpoint, not from examination viewpoint. Engineering is very vast, I know. And not only civil, all are very vast engineering. And it's mind work. It's work of mind and work of body and work of soul. We may not recognize soul because science doesn't accept it. But I accept it. When I am spirited, I work better than when I am not spirited. Spirited means energized. I am not saying a spiritual soul. I am saying energy. Energized. When you are energized, you work in a better way. When you are fresh early morning, you think in a better way. Because your energy is abundance. Is an abundance at that time. Somebody says you are using software, you are missing a lot. I say yes, that's right, you are missing a lot. Can't you design without software? This is why you are talking, it's not possible these days. Software are best. Okay, software are best, I understand. Can you design yourself? My question is that. Why are you in haste? After all, software is also made by someone, some engineer behind that. So it's only for use. But I say, can you do it from first principle without aid of software? Can you do it? Your answer is no. You say no. Why no? Why no? If suppose today there is no computer, you won't be called engineer? Think of this. Today there is no computer due to whatever reason. Or I don't want to give you computer. I want you to do yourself. Yes, you can take time, no problem. Can you do that? If you can do that, then I can say you are engineer, you understood something. You learned it in the way it should be. That's okay. Engineering is something multi-purpose. It's not one purpose. Engineering is full of intelligence, full of thinking, full of coordination, full of correspondence, full of multiple directions. No engineering is independent nowadays. No engineering is independent, just like our body it is. All parts of our body work together, and that's why we are healthy. Otherwise we won't be healthy. You can learn it from your body, all parts work together, and then we say we are this and we are that. That is beauty of engineering. All parts work together, and we say fine, I'm an engineer, I am civil engineer, I am mechanical engineer, I am electrical engineer. Okay, you have fraction yourself. You have fraction yourself. I didn't ask you fraction. Fine. You are at least something. That's fine. You are fine. Can you devise methods yourself? Methods of doing job? Yes, you have procedures in designs for that. Okay, fine. You have procedure for every design and analysis. You can do that. That's one part of job. That you can deliver drawings or details of whatever proposal is there. You can do that. But did you ever think that whatever you give on drawings or on other documents, what is in your mind? In your mind there are always quality. Quality which is an integrated part of quantity, because when we say quantity is this much, this means it should not be quantity only, it should be qualified quantity. Qualified quantity or quality quantity, both are okay. If your quantity is not quality, then this is not acceptable. That is what engineering is. And only problem now I am saying is this: I have quantity without quality or without full quality. It's full or part. Quality is quality. Quality actually means art. It actually means, standards, expected standards compliance. Or you can say it is something which is much more than that. You are going to be an engineer or you are an engineer. You are certain of that, say 90%, I will do that. This means this is your quality of changing yourself. You are saying, I will become that. You have confidence in you, that's why you say that. And confidence is engineering, confidence is quality. This means if you do something, you ask someone or you do yourself, you are bound by your own that whatever you do, it should be quality based. It cannot be just you do it and let it go. It should be done in a way it's required to be done. It should serve purpose for which it was designed for or done for. If you cannot do quality work, your work has no meaning at all. It's waste of material, it's waste of energy and time and money. This point I am very serious about. Quality is a must if quality is a must if quantity does exist. And if quality does not exist, then you are not doing your duty, you are not doing your job, you are cheating yourself. So simple. You are cheating yourself. I am cheating myself. Everybody is cheating each other. Why? For what? For what? Why we cannot understand that quality stays at number one. This is not product quality, thus quality at every step we take in that green or brown project. We have to understand this point. If some engineer does work without quality, that engineer does not mean that he is no good engineer. But what is quality? Point is that what is quality? Imagine and remember, if there is no quality, what should be there? Rejected material. If there is no quality, or to some level, acceptable level, there is no quality, what shall you find? Rejected materials. All rejected materials and rejected personnel. Why our new engineers often not fit in professional activities because of this reason. There is no meaning of doing so many subjects study if you don't use them in your career. So your education is not quality education in that case, because whatever you learn you are not going to use in your professional life. So what's the purpose of learning that? But if you use that what you learn, you can say yes, you have learned something. Is this learning is coming used to be used in your life? This learning is fruitful, it's meaningful. It's not that it's no meaning I just learned. I am just defining engineering management. I'm not, it doesn't mean that I'm going to discredit someone or I can say discourage someone. No, that's not the viewpoint. My viewpoint is different. If you can achieve everything in life, in profession, it's very nice, very good. You have, demanding approach in work, it's very fine. Demanding means you demand every activity, every quality point, every quantity point from those working in field. Through contract or directly, very simple. If you can demand quality, you will get quality. But before that, you have to understand what is to be demanded, what quality you expect of. I don't say you go to courts, and that's not my intention to state here. Forget that. Forget courts for example. First you think what quality is. No courts can teach you quality. No professor, no engineer can teach you quality. You have to use yourself, your writings. You try to write, maybe you will not accept, you try another writing. How fast can you not accept it? You will accept it. Well, there is no end to this discussion for quality and all that. It's very different, and I can't take more time on this. Already about 1 hour and 20 minutes have gone on this unscripted talk, and I usually talk unexperience. If your mind is, if your mind generates thoughts, it's enough for me that I understand what is quality. Now I am jumping onto my material world. That's actually engineering, and material engineering you can say, or I name it soil engineering because I consider soil is only material, that is father of all materials. Maybe you people not convinced with this, but this is my convincing, my understanding that soil is real material. And there is a question also about this first material, and I think soil is very, very important material. I have to think about. I till yesterday talked of soil, etc. And unfortunately I could not upload files, or those files which I want to share with you. I could share some, but I think there's some improvement on Facebook. There's some change of architecture on its design or space, and maybe I get share screen command. Maybe within a couple of yesterday I tried it. It was there, but it's not complete, so I could not upload. I can say I could not go on live with those files. Those files I want to share with you. Maybe when this system is ready, I'll upload those. I'll go live with those files. That's just same file I'm going to discuss with you, and also I discussed some file yesterday, and also there's one more file. And whatever files are there, then we can say soil testing files. Whatever small information I have, I will try to share with you. And because then I'm also interested in something else about dissemination of knowledge of engineering to world, and to particularly students of engineering and persons involved in this. My mission is that engineering is well understood and with quality. Quality must be taught to everyone from top to bottom, because observations clearly reveal that we are very short in quality. We don't understand quality, and when we don't understand quality, we cannot deliver that. Quality is hunger for me, because if there is no quality, your money is wasted for nothing. And money is not to be wasted for just for nothing. Again, economics is there, and I consider, you can say engineering economics, I can say, or economic engineering, I should say, it's something like that, and that everything is okay or not okay. That's different things. Now, I will open that file which I was talking yesterday and see how can we move further. And meanwhile, I forgot to do scanning work. Let me open it again. Maybe I can do it. I'm not sure. I forgot actually. I have to put scanning on. Well, that's not a problem. Now, what happens when I talk? I lost myself. I lose myself. Not loss. It's my weakness, you can say, possible weakness. And now I'm going to, this is modern light analysis and magnetic micro stuff. Yes, it is that file, and I talked something about this file yesterday, and what I discussed yesterday, I brief it a little, and then we go further in this. And I think before I start, I should go to little activity of mine, and we go to for 2 minutes for some, I have to put food for cows. Hold on, please, just for 2 minutes and come back. take care of the birds' food. Also, this is my responsibility. Here I'm alone here, so no one here to help me. Problem. Yesterday, I was talking about microstructural analysis and magnetic characterization of native and magnetically modified montmorillonite and vermiculite. And before that, I had talked about some other file, and that file was, if I remember, it was affect montmorillite, an introduction to properties and utilization. And there shall be another file also after I complete this file, and that shall be I think well, I don't know what's that. It's regarding curves actually. I don't exactly remember what this file is. No problem. And I also discussed before this soil thermal resistivity, etc. I'm taking step by step this is about electrical rock soil and all that. And then before I took this stabilization and stone columns and all this we have talked. This is now we are talking about you can say magnetic assay. This is microstructural analysis. Microstructural, you know what's microstructural analysis means. We have to use microscope and study what is the structure, what sort of structure of the soil elements, soil particles. And magnetic characterization means of native and magnetically modified montmorillonite and vermiculite. Means what is basics of domicile of that magnetic characterization of that we can understand by using that method I described yesterday, not in full but in refer, because I don't have details of that. I don't book, I cannot discover. And also modified means magnetically modified montmorillonite, or you can say clay, and vermiculite. And we also talked of what's the variations on or difference or effects on a structure of octahedral and you can say tetrahedral structures or layers of these montmorillonite, calvite, all this, and how it affects on vermiculite and montmorillite. That's the point yesterday we discussed with. And there was reference this file. I again say that this is not my file. I'm just referring to this one. And this is an actually article written by so many people, so many thinkers, you can say, so many scholars. I'm just for reference trying to explain to you through that, though I can explain separately also, but because I don't have that much details currently in my hand, I have to search out. I explained to you about how this triangular structure is understood. Triangular means triangular in one triangle, equilateral triangle. Then another equilateral triangle in post and that photograph I showed to you that day. In our world we call it, we say Shakti shine in our dharma, or it's also called David of David, it's not Mark of David, Mark of David, yes. That's in Christianity they call it Mark of David. It doesn't matter as far as name is concerned. This is triangle and above, reverse there's a triangle. So there are 6 corners of that triangle. And there's one hexagon form in between. When you make this figure, there's internally one hexagonal, and there are, you can say, six triangular, equilateral triangle, small corners around and in a whole. And also, then you can say there are octahedral and tetrahedral, say octahedral units, and this signs, and there are layers, and we talked of yesterday about this is structural. And then there's a continuation of that. We talked of about, it was regarding this. This is, you can say, this figure we showed to you, talked to you regarding the basic structural unit of phyllosilicates, and then we said that means each sheet of octahedrons, This is integral part. Integral part forms sheets of octahedrons, and which share not only vertexes, this vertexes of this double triangle, and inside is hexagon, but also a half of edges, edges. Octahedrons are tagged together by octahedron plane. Octahedrons are tagged together by octahedron planes perpendicular to, so that there are three anions. Anions form a lower layer. Anions, form a lower layer, and three anions, you say 3 anion called lower layer, and 3 anions are installed in upper layer. So upper layer and lower layer anions, and this, and in between this exist octahedral cations. So cations are there in between to each 3 anions in those 2 upper and lower layers. And mostly I know aluminum and Fe, ferric and magnesium are present in octahedral cations. The occupation of structural positions in octahedral shape generates trio-tetrahedral shapes. So in between these 2 layers are octahedral, and it says that occupation of structural positions in octahedral sheet itself generates tri-octahedral shape silicates, where each O and OH surrounded by 3 divalent cations like Fe2 or Montmorillonite layers. As this is different figure, you say. In this figure which I show next one, just continuous one, in which upper and lower layers, as we said, are tetra, and in between those 2 is octahedrons, and is having, you can say, have aluminum, this aluminum, and this is here you can say surrounded by 3 divalent, like this O and H ions. Occupation of structural positions in octahedral shape generates tri-octahedral shapes, which each O and OH is surrounded by 3 divalent cations. 3 divalent cations like Fe2 or Fe, or you can say Montmorillonite. This is, and essentially clay mineral can be modified in 2 ways: in interlayer spaces, in pursuance of swelling, interlayer spaces in pursuance of swelling, and cation exchange, both interlayer spacing, pursuance of swelling, and cation exchange, and on surface there will be adsorption process. So in this there are all 6 units, 6 points are there. One is aluminum and ferric, third one is hydros, and then hydroxide, and then MgO and Si. These are there. Also there's another one, this A, same way another one is there which talked yesterday. Now an excellent to say Montmorillonite and vermiculite are used as effective solvents for removing toxic ions. So you can say these are purifiers also. One way is Montmorillonite and vermiculite. We can use them as effective solvents for removing toxic molecules from wastewater. So wastewater can be used for treatment. Treatment using Montmorillonite can be used for treatment of wastewater. This is Montmorillonite and vermiculite. These minerals can be used for treatment of wastewater or other compounds. In other years, we can say new methods are designed to improve sorption efficiency. Decrease price of purification technology, and enhance functionality of a material. In order to improve absorption, properties of clay minerals, absorption properties of improve in order to improve absorption properties of clay minerals, different acid activation and other chemical procedure modification will develop. Most of are developed to improvements of clay minerals from viewpoint of their applications. Clay minerals modified by metal oxides, you can say clay minerals modified by metal oxides in their interlayer species are known as pillared clays. It's an important point. Clay mineral modified by metallic oxides. Clay minerals modified by metallic oxides in their interlayer species are known as pillared clays, and oxide particles act as pillars, columns. Oxide particles act as pillars and keep silicate layer apart, and form two-dimensional molecular sieves compared to original clay minerals. They have a higher fraction surface area. So what we say that these acids of these clay minerals modified by metal oxides in their interlayer space are known as pillars, and these pillared clays oxide particles act as pillars and keep oxide particles act as pillars and keep silicate layers apart and form two-dimensional molecular sieves compared to original clay minerals. They have a higher fraction of surface area. In present day, main attention devoted to analysis of complex structural and magnetic properties of magnetically modified montmorillonite at 70 and vermiculite using iron oxide particles. And this is main attention is devoted to analysis of complex structural and magnetic properties of magnetically modified montmorillonite and vermiculite using iron oxide particles and of original unmodified clay minerals. Structural properties and morphology and chemical compositions are determined by X-rays. Structural properties, morphology, chemical combinations are determined by X-rays, fluorescence, spectroscopy, X-rays, fluorescence spectroscopy, and scanning electron microscopy, that is SEM, scanning electron microscopy, transmission electron microscopy, TEM. So there is, can say one is X-ray based XRFS, which is X-ray fluorescence spectroscopy. Other one is scanning electron microscopy, that is SEM, and transmission electron microscopy, TEM, and X-ray diffraction, XRD, macro magnetic characterization of samples are achieved by magnets and Massoba measurements at room and elevated temperatures, completed by low thermal measurements. So what we say, we can understand properties, I can say morphology and chemical composition by using X-ray spectroscopy. You can say X-ray fluorescence spectroscopy and scanning electron microscopy, SEM, and transmission electron microscopy, that is TEM, SEM, and this is TEM. So one is electron scanning and one is transmission electron microscopy, and then X-ray diffraction, XRD, X-ray diffraction, and macro and micromagnetic characterization of samples are achieved by magnetic and Maslow measurements at room and elevated temperature, completed by low temperature measurements. Then we did experiments and sample preparation, all this was shown. I'm not going to repeat that because that takes time. So this is regarding that transmission electron, and there's one before that other one, SCM, this SCM, this is electron microscopy. We just now said SEM, that is, it is, you can say, scanning, scanning microscopy, electronic microscopy, and then the XRF, X-ray fluorescence, and that is the other one is, and then there is transmission electron microscopy, then X-ray powder diffraction, XRD, Masobar spectrum is there. We studied all this with formula and results we discussed very, very keenly, and results of chemical analysis, original, which is results, the problem is that, results of chemical analysis of original and modified, you can say, modified, not modified, this anti-monoclide and vermiculite light and magnetically modified both samples using XR fluorescence and electronic diffraction rays are summarized. Increase in content of iron oxide after magnetic, increase in content of iron oxides after magnetic modification is evident at both samples. This is increase in content of iron oxide after magnetic modification is evident at both samples, and both is some small amount of wustite, etc. done. So we'll move further on this, and this is, then we can say we got more details morphology of vermiculite and monoclides, more details morphology of vermiculite and monoclide samples in their original, that's work and MAP, and modified M work and MT states in seen in TEM microscopy, that is transmission electron microscopy, and they document that submicron iron oxide nanoparticles occur at surface and integrain at MWAT and MT samples, and that their size is surprisingly larger at MWAT sample through preparation procedure was same for both. And we can say that minerals are highly sensitive. We says that corresponds with difference of XRD patterns of magnetically modified samples in next subsection. It also says that minerals are highly sensitive to chemical composition and to strong texture, consequently, and layer nature. And say minerals are highly sensitive to chemical composition and to strong texture, consequently, layer nature, as it follows from more detailed studies of vermiculite and or monoclide taken from various geographic regions. Analysis of both magnetically modified samples did not yield any input of iron oxide, you can say, nanoparticles into interlayer. You can say analysis of both magnetically modified samples did not yield any input of iron oxide non-particles into interlayers. So did not yield any input. A complicated composition of both clay samples was good. Its reason why it's a complicated composition of both clay samples was a reason why more detailed analysis of these patterns has remained out of present study. X-ray pattern in figure have only document a difference between original and magnetically modified state. This difference is remarkably higher in low angle region. low angle region for 2 theta between 10 and 40, and upper panels, namely at vermiculite, outstanding peaks in both vermiculite samples at 2 theta is 21.79 degrees to 29.07 degree, and then it goes to 36.48 degree, and then 44.27 degree to 52.07 degree. Yield nearly same position. At present can be only speculated that magnetic modification did not affect structure of sample. From structural viewpoint, more detailed studies of both model 5 claims should be done. There is nothing achieved in that. Since now molecular spectroscopy, molecular spectrometry we did with this one also yesterday. This is molecular spectra or original MT1 and magnetically modified MMT and MER. Monomonolite and monomonolite and vermiculite samples recorded at room and low 7K temperatures. 7K temperatures are depicted in figures. Low and room temperature and low 7 Kelvin temperatures are depicted, while X-ray diffraction yields information on major minerals and clays. Mesobar spectroscopy looks selectively at iron containing compounds that are often difficult to detect by X-rays. Diffraction due to their low concentration, small particle size, or poor crystallinity. Nevertheless, also a unique interpretation of Mesobar's spectra can be sometimes difficult or impossible. Either because a spectrum cannot be decomposed in a unique shape. Sometimes it is helpful to supplement measurements at ambient temperature by measuring liquid nitrogen or helium temperature. Iron may be present in both minerals, on positions with tetrahedral or octahedral oxygen environment. This can be distinguished by hyperfine parameters, namely isomer. Hyperfine parameters, namely isomer shift and quadruple splitting. So quadruple splitting. Mass per spectra for water sample in its original state collected at isomer spectra for water sample in its original state collected at 295K and 7K are shown in figure. Upper panel, low temperature spectrum yields a weak magnetically broadened 6-line component. This low temperature spectrum yields a weak magnetically broadened 6-line component with relative area of 3.6%, pointed up in black color in the same way as in other spectra. Its hyperfine induction 51 P is slightly lower as obtained by other authors. Now, small relative area as well as isomer shift, and small relative area as well as isomer shift delta 0.37 mm per second, and quadruple splitting delta EQ is equal to minus 0.4 mm per seconds make difficult an assignment to a specific oxide or oxyhydroxide. Or magnetic modification of vermiculite has contributed to an increase in relative area of magnetic components to 9.8% at RT and to 18.2% at 7K. 7K, what's 7K? Okay, hyperline parameters obtained by analysis of RT super spectrum B is equal to this, delta is equal to this, and x equal to this maybe, and of low temperature spectrum B is equal to this, and reflect rather complex iron oxide, hydroxide, and oxyhydroxide due to presence of Al, Fe, and T1 cage cations and anions, part either of oxygen and of hydroxide group. These results are supported also by the fact that lower temperature spectrum consists of not only single sextuplets but also hyperfine induction representing mean value of Gaussian hyperfine distribution with a width of 4.962. A more detailed assignment to a certain components also difficult because of variations and crystalline dominant parametric fraction of all spectra has been fitted by 4 symmetric doublets whose parameters are listed below. For vermiculite samples and with both temperatures double with isomer shift of Ca 100 per second can be assigned to Fe11 iron, and the small one around to agreement with other authors. Amount of non-based compounds in original montmorillite sample now is a result of chemical analysis. Monbus spectra are presented under panels. Parameters of doubles and summarized for both RT and low temperature table. Magnetic 6-line components are seen in magnetically modified montmorillite NM occupying relative area of 11% of RT and 5 to 10% low temperature. Hyperfine parameters obtained for MMT sample of this are typical for non-crystalline particles. Now we go further on this. This curve which I showed you yesterday, magnetic field and magnetization. This was in curves based on magnetic field, and for both showed this one. Let me stay here for some time. Now it says now presented by this says moreover particles in this is motion. Now say okay. This bottom's okay is come at me. Maybe it's okay. Let us take this on the water. Now see something, its room, what it says, room temperature T is corresponds to 300 K, and low temperature LT equal to corresponds to 2K. Magnetic parameters of original is modified, both modified vermiculite and magnetically modified MBR, MMT, vermiculite and marmalite samples. M is magnetization and MR is remanent magnetization. Element H is coercivity. HC is coercivity. Interparticle magnetic interaction. Interparticle magnetic interactions with interparticle magnetic interactions with analyzed by Hankel plots using while original samples behave practically as non-interacting systems. Let's say original samples behave practically as non-interacting systems with very low negative magnetic dipole interactions not presented. Several times stronger interactions were observed for magnetically modified samples. Positive exchange interactions dominate in MMT samples, modified, due to low distances among separated very small nanoparticles. Interaction maximum is detected in magnetic fields about 60 to 80 Ka per meter. Contrarily, in modified vermiculite, modified vermiculite, large objects of small but agglomerated particles contribute to a visibly higher distances among them. Consequently, negative dipole interactions with maximum at lower magnetic field 11 Ka per meter reveal means that particles interact mainly through their total magnetic moments. Thermomagnetic curves of samples in original and magnetically modified states are presented in figure 10. Measurements were done in an external magnetic field of 8 Ka per meter, and due to small magnetic moments of both samples in original states, water and curves are not smooth, and measurements reach a limit of equipment sensitivity. Magnetization curves at increasing temperature. Magnetization curves at increasing temperatures consist of two parts. Red dashed lines better resolved at what samples. Part decreases to 0. TMC curves in figure are visibly different due to magnetic modification reflecting changes in Phi-based compounds. Curie temperature Pc3 corresponding 8 to K for MR and MNT samples corresponds to a paramagnetic transition of magnemite. Gamma is Fe2O3 and say thereby supports mass bowel results. Other two temperatures, nail temperatures and Tn1 and Tn2 are very probably antiferromagnetic paramagnetic transitions of coal from iron oxide and oxyhydroxide compounds. Cooling of all samples back to room temperature returns them into a weak ferromagnetic and or anti-ferromagnetic state with different monetizations include indicating irreversible changes in magnetic behavior of powder treated up to 1073 K. Behavior of all samples below RT is documented by FCZDC. ZFC curves and hysteresis loops at 2K shown and shown here. Shapes of these curves of work and empty sample is practically identical, showing slow changes at magnetization from 300K to 25K, followed by its sharp increase from 25K, 2.5K to 25K to 2K. Such phenomena are already observed, like this hermite nanorods, or CEO2F, Y53 nanocomposites, and could be ascribed to magnetic phase transformation coming from ordering of surface fields at low temperature and resulting in prevailing exchange interactions among iron oxide particles and increase of magnetization. Low temperature magnetic properties of magnetically modified MWT MI samples. All of this dye out my sheet. LT loop of samples in both original and magnetically modified states document that their saturation is not achieved even in applied external field of FIDIC. Main reason could be in presence of metal and ionic compounds in different influence of ferrous and ferric iron in very small grains, and also in a direction of applied field with regard to direction of shapes. All magnetic parameters determined from LT loops of original and magnetically modified samples yield higher values compared to RT parameters. ZFC curves for MWT and MMT sample differ. ZFC curve of MWT impulse shows at a typical behavior when it decreases nearly nearly, linearly with decreasing temperature and about 25 K and inexpressive. So what is actually conclusion here? Let's understand that. Mount Morillonite from smectite group and vermiculite from vermiculite group. Says Mount Morillonite from smectite group and vermiculite from vermiculite group were magnetically modified by mixing original clay minerals with iron oxide particles. Clay minerals, original clay minerals with iron oxide particles prepared using a microwave, FIDIC microwave irradiation procedure. Yes. Complex structural and magnetic studies of original and magnetically modified powders were performed using scanning and transmission electron microscopy, X-ray fluorescence spectroscopy, X-ray diffraction, Masaba spectrometry, and magnetic methods at room temperature. At room temperature, most of results is supported along also by low temperature measurements. Both clay minerals are of 2:1 layer and type and SCM observation yield similar morphology and large area as local chemical homogeneity of all studied samples. Nevertheless, TEM's micrography clearly shows large particle agglomerates at vermiculite sample, contrary to Mount Morillonite consisting of very small separated nanoparticles. Original clay mineral behave as in a way corresponding to their composition. Vermiculite with higher content of iron-based compounds, yield slightly softer magnetic properties and presence of magnetic component in low temperature, while Mount Morillonite is permagnetic or super paramagnetic at both room and low temperature. Magnetic and modification changes magnetic properties of both samples in magnetic properties both samples room and low temperature magnetic modification changes can say magnetic properties of both samples in different ways. Particle agglomerates in vermiculite cause magnetic hardening. Particles agglomerates in vermiculite cause magnetically modified, sorry, cause magnetic hardening and prevailing dipolar interaction or dipolar coupling, which refers to direct magnetostatic interaction between two magnetic dipole moments. Contrary magnetically modified monopolar light exhibits supermagnetic behavior. Modified monopolar light exhibits supermagnetic behavior at RT, at room temperature. Room temperature with clearly nearly zero coercive field and remnant magnetization. It means that temperature fluctuations of nanoparticles easily overcome barrier consisting of their anisotropic energy. Marked increase of Hc at 2K. Marked increase of Hc at 2K confirms that during cooling, magnetic nanoparticles attract properties typical for magnetic order materials and pass into blocking state PV corresponds 150K. Now, experimental data used to support findings of this study are included in the article. I will read it once again and then go back to see if we can do something against this, because others are references only on the other pages, so I will not go to references because of some reason here, and that what I'm saying is I'll read this conclusion once more and I see what to do with that. And before that, I would like to see something if I can, meaning of that. And it is, it's actually very interesting if you understand that. It is value of K. RT is room temperature and low temperature K. Let's understand that, right? Room temperature, room temperature, and low temperature, Okay. Actually, room temperature is actually range of temperature from 15 to 25 degrees, corresponding to temperatures comfortable to people. 300K is generally accepted value for room temperature. 300K is generally accepted for value of room temperature to simplify calculations. Abbreviation RT or RTR commonly is the chemical equivalent to denote reaction, can be done at room temperature. Low temperature mechanical properties, and that is, this is fracture toughness test conducted at room temperature. 77K, 4K mainly for GS class 2, commercially pure titanium, oxygen well room temperature is a horrible condensation. So RTK is a horrible condensation curing temperature. I'm not finding anything special on that. Leave it. Not this time. There's nothing there. Leave it. So we continue this. It's an interesting one. Let me read it again. It's conclusion, because I'll discuss something else as well. It is I speak gradually. It is I can say just the conclusion of this article, which we should understand each already 5.5. Conclusion of this, though this article is not very perfect, informative, we should say. Okay, gentlemen, let me see what's happening on YouTube first of all. What's going on? Let me see carefully that. Let me see what's going on there. Yes, it's still going on there. I don't find any problem in this as well. Oh, sorry. Okay, so I do it now. So I keep on like this. So I start with this, you can say. This is what I'm talking now, is a conclusion of this article which you gave before. I'll see that curves etc. also that it's not completely given. It's a Montmorillonite, Illinois, we have to understand more the composition, so we should be clear about this. Illinois from smacktite group. So group is smacktite. Montmorillonite from smacktite group, and vermiculite from vermiculite group were magnetically modified. Both items, Montmorillonite and vermiculite, were magnetically modified by mixing original clay minerals with iron oxide particles. Original clay minerals with iron oxide particles, prepared using a microwave, using a microwave irradiation procedure. Microwave irradiation procedure. Complex structural and magnetic studies of original and magnetically modified powders. Complex structural and magnetic studies of original and magnetically modified powders were performed. So original clay minerals were added and iron oxide particles we mixed with them, all spectacle is non-moralized and moralized, magnetically modified by mixing original clay minerals with iron oxide particles, prepared using a microwave irradiation procedure. Complex structural and magnetic studies. Structural and magnetic studies of original and magnetically modified powders were performed using scanning and transmission, electron microscopy, scanning and transmission, magnetic studies, were performed using scanning and transmission, electron microscopy and X-ray fluorescence spectroscopy, X-ray diffraction, Mossbauer's spectrometry, and magnetic methods at room temperature. Most of result is supported also by low temperature measurements. Say the magnetic methods at room temperature. Most of results supported also by low temperature measurements. Both clay minerals are of 2:1 layer, type, and SEM observations, scanning and transmission. Scanning and say transmission. So scanning, electronic microscopy observations. Both clay minerals are of 2:1 layer, type, and SEM observations yield similar morphology and large area as local dot chemical homogeneity of all studied samples. Nevertheless, TEM micrographs clearly shows larger particles agglomerates at vermiculite sample contrary to monazite. So it says, nevertheless, we go that now a little because I'm trying to understand as well. Nevertheless, TM micrographs clearly show larger particles, agglomerates at vermiculite sample contrary to monazite consist of very small separated nanoparticles. Original clay minerals behave in a way corresponding to their composition. Vermiculite with high content, vermiculite with higher content of iron-based compounds yields slightly softer magnetic properties and presence of magnetic components at low temperature, while monazite is paramagnetic. So says that magnetic modification changes magnetic properties of both samples in different ways. Particle agglomerates in vermiculite cause magnetic hardening, and prevailing dipolar interaction, dipolar coupling, which refers to direct magnetostatic interaction between two magnets. Particle agglomerates in vermiculite cause magnetic hardening, and prevailing dipolar interaction of backward coupling, which refers to magnetic hardening and this vermiculite, and prevailing dipolar interaction or dipolar coupling, which refers to direct magnetostatic interaction between two magnetic dipoles. Contrary to magnetically modified monazite exhibits So Contrary, the magnetically modified mountain light exhibits super paramagnetic or you know, modified mountain light exhibits supermagnetic behavior of it means that magnetic exhibits contrary magnetically modified mountain light exhibits supermagnetic behavior in room temperature with nearly zero Hertz field and remnant magnetization. It means that temperature fluctuations of non-particles nanoparticles easily overcome barrier consists of their anisotropic energy. So this way, say this way, just for 2 minutes so that I can change direction. So contrary, I can say it means that temperature fluctuations of nanoparticles easy like that. It means that the temperature fluctuations of nanoparticles easily overcome barrier consisting of their anisotropic energy. Marked increase at Hc at 2K confirms that during cooling, magnetic nanoparticles attract properties typical for magnetically ordered material. So this was, something about these curves, which are some curves. Let us see what are these. here say that this is PC and FC and ZFC to 1. Also magnetization, and this is magnetic field. This temperature, here in this curves we are doing something here. It says magnetic field is mentioned and temperature, and then mass, and then mass magnetization. You can say this is magnetic field and mass magnetization, and this is temperature and mass magnetization. I will show you these curves. Actually, these are one is magnetic field, other one is temperature versus mass, and one is here, that is magnetic field and mass magnetization, and other one is temperature and magnetic mass management aims to that's a figure I give you, photographs of this. It may take some time. Sorry. say, this is now giving you these are given covers here, curves, graphs. So I'll just explain about this. Now, these curves are given 4 number here. And these are related to magnetic field, magnetic resistance. It is one. It is a magnetic field. So this for courses wise, you see that's a curve magnetic field KAM. That says magnetic field KA per meter. And this is temperature is -5 down to -10 down to -15. Or you can say this is this is, you can say, magnetic field KA per meter. And when you say magnetic field and mass magnetization, There's another curve which is temperature versus mass. 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 You see, when temperature rises, these curves are very critical one. If you can browse to these curves, there is PFC and this ZFC2 are there. Increasing temperature, gives you mass magnitude. Alright, and see, in this case also temperature rises from 0 to 200, and also mass magnetization happens from say 4 and goes down to 0.6. So this way you can see these curves are very, very special curves. Magnetic field, magnetic field at Ka per meter, and also magnetic field. Then another one, that's temperature and mass magnetization. Alright, now I'll go to other one. You can check these curves. There are two types of curves in this. One is FC, that is temperature K, FC and ZFC. This indicates that two lines, and TB and TR. Ultimately, if you rise temperature and you go away from say 100, you will not find much difference, and if you go there, similarly, if you say temperature is rising here, you know, and mass approximation. This is mass approximation. Now, these curves can indicate you what we learned in our. I will record these files if possible, and then we'll talk. Now, let's open now new file, and that is it's not that. What's that curve? I'm sorry. I should understand this actually. Electrical is that? I think it's inside. Okay, let's go inside. What is that? This is stretching. Yes, it is I'm going to talk now just for information, not explanation today. Only information because I have to talk to FIDIC also. It's of course little technical, very much research oriented. Yes, I open this file. This is a month, model and night. differential thermal curve, general variability in dehydroxylation region. This is by R.C. McKinsey. Month-moralized differential curves, thermal curves, general variability in dehydroxylation region persistent. See. Let's start this for purpose of month-moralized differential thermal curves, and this is by Robert C. McKenzie. Summary is various type of curves given by month-moralized samples are discussed and compare possible reasons for difference are considered. Exchangeable cations and fixation of cations. Paragraph very important. Various types of curves given by month-moralized samples are discussed and compared. Possible reasons for differences are first, exchangeable cations and fixation of cations affect not only hygroscopic moisture region but also dehydroxylation region of curve. Dehydroxylation region of curve. Reason for this can at present only be surmised but eventual solution would with undoubtedly lead to clarification of truths monitoring. Through monitoring structures. Just going to brief this announcement that I'll just read it for you people because I will record this in video share if I could. See that typical month moralite is usually considered, a typical month moralite is usually considered to give a differential thermal current. A typical month moralite is usually considered to give a differential thermal current. It's a big deal actually. I should read full this paragraph. It's parts is good. File itself is, I think it's not a very big file. This is just 11 pages. File is not a question mark. The civil current is very glossy, but I do also. Right, now we say let's do something like this. It's little difficult here try to do because I can't leave it. But I was just thinking how to handle this because I don't have a referral of this. I don't have that copy which I can show to you, unfortunately. I'll get it done and give it to you. Meanwhile, I will change this. After reading this paragraph, I read it again for you because it's soil and it's very important curve. There are so many curves in this paper. This is about 11 pages and they have curves here. This paragraph is there, then there's a group of curve, non-polar line differential curve curves. There is then another curve. These are about 6 curves in this A, B, C, D, E, F. Then there is another one. This complete detail is given in this. The another group of curves, same one with differential thermal curves. These are called the physical curves for a light and places and see that. Another group of curves, the curve curves for beyond bentonite. This for bentonite and previous was this is for different for elite samples. Then there is another curve which is same, and then there's another curve which is for snap, smack type. Then there's one more group of curve which is for cantilever filler system. Cantilever filler is for up, below. Then there is another one which is Wobar fillers or Wobar fillers. Also, there's the description of references here, and there's an appendix here regarding what chemicals, percentages, and all these 6 and 80, 69 up to 81. 80, then it is 69, and then it is that CC and 100 gram. We'll see what's that, and then there is another impurities detailed are the quartz, opaline, SiO2, feldspar, colonite, spin, and others. Interventions are there. After that, you can say this is 1111. We'll take up this discussion next time because we'll see what we have done so far. We have to take this next time, and I think then we'll take up your soil investigation of that. In this case, case of soil, we have to we have gone through many files so far, except which I'm not going to tell you. We are going to say stone column method in geoengineering projects, and also we learned a lot from that. We have also gone through granulated blast furnaces like in engineering behavior of stabilized topsoil, and also ground soil resistivity. We have gone through bitumen soil stabilization and control stiffness columns. We have gone through this ground improvement services, and I have moved to deep soil mixing, ground improvement. Then we have gone through, you can say, deep soil mixing, ground improvement, electrical, what is soil resistivity, definition and measured soil resistivity, and hydraulically bound material and cement bound granular material, and also lime and cement stabilization contract, Montmorillonite microstructural analysis and magnetic characterization of native and magnetic soils, Magnemite difference with thermal bending, then you can say Montmorillonite we discussed here, only one is left. There is introduction to population and utilization discussed, and soil modification will by also. After that, we have gone to soil modification, fill drilling, and then thermal resistivity. All these files will go on later on, and then vibro stone columns, cost effective and ground developments, and water stone columns. This file we have gone through. These are very effective files, and effective in a sense, you can say we learn a lot from them. say that gone through that. Now here we are back for now it's I will discuss shift into contracts, which is very important part. This soil will take up tomorrow because actually it's so boring. It happened never with me. Okay, gentlemen, now we talk about this contract, which is very important part, as I always say. I always say that, and I believe it. It's not saying only; it's believing also. Where is that part? I was yesterday. I don't know what's the one. Something missing here. Let me see. It's the same file. Yes, it's the same file. rise. What's the reality? Sometimes, got it. I was from, it's 5-1, sorry, not 6-1. Designs, designs. As I talked to them yesterday also about this designs. What actually we do by that design is the obligation on the PC side. Actually, what are obligations on APC we have to understand. That point we have to understand in common sense terms, not in in terms which not that we understand, in terms that is the right one. In those terms, it should be right one. Means I was performing this right. We should understand design, but in design, first we have to understand what is EPC as we discussed yesterday. We discussed something technical also. That's okay. I explained many points, also examples. Remember, when we say EPC, this means actually it's full complement. It's total content. Engineers, says, have to understand this is EPC, this is not an ordinary contract. Not an ordinary contract. If you are not pushing that person to understand what's required. I was just thinking of something before expressing that. Because sometimes you have to think differently, not according to what you have to say. EPC is engineering, procurement, construction. Construction which is done at end, and engineering which is done at beginning and throughout. EPC itself is complete design. I'm not talking of specific design, complete design. Engineering project, engineering procurement, engineering construction, all are engineering. engineering, engineering procurement, engineering construction, engineering maintenance, and then operations. Once engineering terms comes in, actually it gives you engineering power to engineering whole content. You are engineer in that case. You have to take higher controls, better controls, rather than just being constructor of that. Of course, construction engineering is there, but that is at end. When we say complete responsibility, means we are given something, you have to think and deliver according to this. According to what? According to my wide dream this project should give. That's very important. Very important point. Of course, we will discuss articles and we will discuss this clauses. But root cause, root requirement we have to understand. I explained yesterday technicalities of this, and I want to confer today about articles of this. What actually articles is like. You buy many items in market. All buy. Everybody buys. And these items are, you can say, consumer goods or whatever. These items are not sold in parts. They don't say, we are giving you these parts, you assemble yourself. They don't say that. That we are giving you these parts, you assemble yourself and operate. Use it. They don't say that. We know it. That is not light based solar. We know it well that we use these items as delivered. At most, if some item is a little critical, that company's representative installs that. That's all. After that, that item works or operates under a fine warranty, and then we keep out after warranty expires on AMC. This is general practice. Now, what I am stating here is, here in FTC, what we are doing, we are doing same thing. Indirectly or directly saying, we are doing same. Means only difference is we are not delivering somewhere, we are delivering on that land. We deliver on that land where project is located. But that item here we buy in market. Here our market is that land. Otherwise, what's function of that? We buy in market. We say this is our specification, this is a machine, and we buy this machine. We are satisfied with this. Or that company claims something that it will work like that. And that must work. What we do here? We design something in all respects and we say it shall work. But it must work. If it doesn't work, then there's no meaning of that. Now what happens? That equipment we buy in market, if that equipment fails to work, yeah, if it's repaired a little, I don't mind that. If it fails to work, it doesn't perform according to what we expect or what is mentioned on that, what happens then? Means, what happens then? That company replaces that. Or if we are not satisfied, if there is a condition, that company says, okay, we will refund you, we will take back our equipment. Either of two conditions. Rarely this machine or equipment is replaced. Either you replace or you sell back, means you give money back, and generally they give money back if it's like that condition, or they replace that if it's not repairable. This happens on those items. Now what is difference here in this transaction and in that transaction? That transaction is called equipment that we bring from somewhere, is manufactured one and delivered to you and installed for your service. And here what happens in contracting site, that we deliver everything on this site completely fit, and that operator has to operate it and use this for whatever purpose it was. Means we are not using it, we are using for production of something, and here equipment is used for your service only, and here there is production something, so that production is service. Now if you compare both, there is no major difference. There's one difference is that we are delivering on location. There is no option. In that there is option. You could deliver it wherever you are required to deliver it. Other option is that you replace it or you get back or you repair. In our case, if suppose we consider replace it, is it possible? Think. It's not possible to replace it or repair it or do this. Means this must work. This installation or we call it plant facility, this must work. What was purpose of this? This was purpose. This must work. And if it does not work, you have to replace it. Can you? It's impossible. It's impossible. You cannot replace it. So what to do? Can you get it back? No, you cannot get it back. So all three probabilities, comparative probabilities, do not succeed in. But what? This means there is no way out, or as there was way out from point of view of that equipment. There is no way out from point of view of this site or this location of plant. This means it must work for sure. No way out. It must work because you guaranteed that as a contractor that this production will work. You will get success in this. Okay, we agree. that it shall work. Now think of negativism. In case it does not work constantly, let us say it works first. It starts, we test everything for 2 months, 3 months, or according to whatever defined in contract. We pre-commission it or pre-test it, and then we test it for successful commissioning, and then it is commissioned and also it operates. But what happens, for example, by chance it shuts down or fails in some location? It shuts down, maybe something happens and whole plant stops due to whatever error. In that case, your plant does not work, say, for 1 month, 2 months, 1 day, 2 days. Who is responsible for that loss? For that loss of production, of a damage, and who, okay, it's your responsibility, you produce that, you deliver that, you say that I will bear this loss. Okay, you bear this loss, but even then you have to use it, you have to recommission it, and again say it happens. Another time something else happens, and again you say, okay, stop it, shut down this and use this. Okay, you repair it, you do it, you replace it, and say again it happens. Let us say it happens many times. In that case, where is your engineering? Where is your engineering in that case? Every time you are failing, every time means your work is failing, where is engineering then? This means there is no engineering. You lied, you cheated, you did not do what was required to be done, and every time you are facing problem, you are paying back money, or you are digesting damages, and you are paying back for damages. This company is losing time and money and reputation and all losses that deliveries were to be made to intended customers or consumers. So in that case, you are not successful contractor, you are not successful guarantor, your track record is not good. So try to understand complexities of such EPC status, because your design, your construction, your everything, your design in total, your procurement based design or design based procurement total, your engineering construction total or construction engineering total, your testing total, your training total, and your commissioning and then operating total, yet it does not work. This means your job is not worth, is not quality done. Only you are responsible, because it's you who did everything for us. That's what I'm saying. This is very dangerous. Projects cannot go on like this. It cannot be done like this. It's same thing. You bought a plane, any plane, whatever plane. It's guarantee of that company giving you plane. It will work like this. You paid money and there is agreement. Your pilots are well qualified, licensed, and you have every very good airport, no problem. But this plane crashes or doesn't fly well. So what shall happen? So your site is same. It's a plane. It's a plane. You cannot fly this plane. Your responsibility. Try to understand this point. So EPC is much higher responsibility. If you get good rates, good profit, and you have to work also. If you buy wrong machine, inconsistent machine, don't forget machines cost millions of units or currencies. Machines cost millions, and machines which you buy, equipment whichever you buy, must be consistent in coordination as well as in interfaces, and that's why we call trains process trains. There may be say 10 equipment in a process train or 20 equipment in a process train, and if one equipment doesn't fit on that train, it's not consistent with that train or its neighboring bogies or neighboring units or neighboring vessels. There's some technical problem. There's some coordinational or interface problem within systems of both this equipment or this engine or this, you can say, machine and previous machine or other machines. Then that train stops. That is what I say. Design is very important here. Design, okay, one is the structural design. I'm not talking that one. I'm talking option for machine. Whatever machine you opt for, whatever equipment you opt for from market, from specialist companies, organizations, we should know which one is right and which is right. If you buy a standard one, then you have to think a lot, because that standard one should fit in. Always know you have order for separate design, you have to manufacture specifically that one. In that case, then it should be working. Whatever indication I'm giving you, that if your trains don't work properly, which is main combination of project, which is main component of project, your project is for these trains only. All other areas, I may say this plant area is a major component of this project, and if this plant area does not work successfully, all other areas are subsidiary areas, supporting areas, everything fails. Try to understand this complication. As I gave you an example, because one civil structure failed, that's called seawater basin. Failed in the sense that it moved at one place, structurally moved to other one by few centimeters, which caused a problem on this side. But howsoever they controlled it. But this happens. And so machines and foundations and all structural still, whatever structures we have, other than all this, heavy structure, heavy foundations, heavy superstructure, we have to construct. EPC is therefore very, very highly professional, experts job. Every ABCD you cannot be qualified to go for this. It's not simple construction. It is thoughtful construction. It is guaranteed construction, and it takes big time, big money, and we have to understand that point. We are not going to crowd machines there or crowd foundations there, or just to see how much we have done. No, that's not our contention. Our contention is not that. Contention is different. Whatever we are doing is workable, is functional, is having certain relations to each other, and has got its relative controls to each other. That's the point that we have to understand. And if we can't understand that point, we shall always lose. Always we shall lose. Therefore, this point is very, very complicated. Very much excellent design, very much good design, and procurement, irrespective of cost factor. You have to understand cost cannot be considered everywhere. And time factor, you have to see your design must be done in time and procurement must be done in time. Otherwise, you cannot erect that machine or equipment and commission it in time. So you must have master type engineers who can do that. It's not master type means who are expert of that word. That's where I say is when E word is added to contract means EP is added to say construction changes to thorough responsibility. Complete thorough. That responsibility is reasonably well, professional. That cannot be taken for granted by either of us. Must be respected anyway. That's what is said. There are so many terms, so many, there are so many other contracts on that project. It's not that you shall suffer only, all shall suffer. All shall suffer because of that. Plant shall suffer, facility plant. You shall suffer, those who work with you, they shall suffer. And remember, no suffering. Yes, that's right, that's right. I was contemplating something about that. Very important point. Failure is not successful. But failure is not, you can say, drastic, you can say, devastation also. I have seen so many changes on such projects during construction. Drawings and then drawings and revised drawing, that revised, further revised, further revised, further revised, further revised. Because of continuous process of design, they issued designs without thinking, then changed immediately, and we had to change during construction many such works. Rework and work and rework and work and rework because of changes and changes and changes. They don't mind reworking, they don't mind. Because reworking is only few thousands or few maximum lakhs or hundred thousands of reals. Yes. But if plant failure occurs, that will be millions. So they don't mind small changes, reinforcement changes or size changes or something. They don't, even if it's required, they can break it. They can break it. No problem. They can break it. It generally happens with plants, facilities. Not talking of structural buildings. It doesn't happen in buildings actually. It happens in vessels, open foundations, where there's sheds. Not RCC structures actually. Only in foundation there's RCC structure. Generally it happens there because all equipment are covered under structural steel building supported by RCC foundation. That's general. I cannot say others cannot be, but this is generally done that way. Because also this is industrial area and they can protect that steel member, vertical stains a column by something, even by fireproof paint or something. And they can use some concrete also for that. But buildings is not a problem. Building is not according to design. Because building is, we are not going to procure building from outside, and we know what specification buildings do have. So that point we must understand very well. Understanding, and I'm not scaring anybody. Really, I'm not scaring. I'm just telling you facts of engineering. As I said, always I say do think and deliver. Think and deliver. This is what you have to think. Even sometimes you have feed that can also be defective, that can also be erroneous, and then you have to design. Then design philosophy can be erroneous or something, and even is that you have to change it immediately before manufacturing of equipment is done. So such plants, even though it is computerized world, everything is there. BIM cannot help it, because BIM can coordinate which he doesn't. They cannot say this machine is bad or good. It's up to you. So sometimes you feel very pleased with such activities, and sometimes you don't feel that. And when I say quality, means all this part of quality. It's not simply quality on site. This is quality of procurement, quality of design, quality of safety, quality of planning, quality of working. Everything is everything. Quality everywhere. That's what I want to explain all this to people, that not just go point by point, because point to point does not mean anything. If you can, after the points are there, one can interpret this way, another person can interpret that way. So what author actually had to tell, you could not understand that, and you do something else. That's why explanation is better than making mistakes. And it's a good one that if you tell, I could not understand something, or and you have to write all these details in some else, in some. Well, EPC is therefore very critical. Though we are saying silver book, why it is silver you can understand. This is silver. We say silver lining. We say silver lining. I say it should not be silver even. It should be iron or steel. It can be platinum as well. So silver is also not very strong that way. Well, I'm just joking about that. It's not silver or not silver, I don't care. It is EPC which is more important. The red is not important, but construction is important. So that is construction of FIDIC, and this is EPC for control. This is a thing that way. And it's EPC, it's complete engineering. EPC, E stands for engineering, and engineering means engineering philosophy, engineering basis, engineering detailing, and everything in engineering. And then also it is procurement, which all items are engineering. There's no way you can say no. And also you say that this is, you can say, you mean to say complete engineering from desk to delivery. Commissioning engineering is also there. Pre-commissioning is there, before commissioning, total testing, and then you can say running of project, or operation of project, successful operation, and then successful coming, and warranty time, and all that. Long journey of plant, and technology is used for so many years. That's also known to us. If Alright, so we have to break our head correctly so that we understand it correctly. Don't keep it closed, keep it open, take out all your analytical values from your mind, not under threat but under confidence. EPC requires, it demands confidence, it demands trust, it demands certainty, it demands no ambiguity. It requires that whoever does it must be confident, matured, and can say consistent and competent. Decision making should be perfect and cost should be kept in mind. Though this is not very important, but some people are behind this. Let them see consequences. You did it, you are responsible. If I do it, I am responsible. That is what it's called. In Red Book, you are same to some extent. And this book. When I say EPC and we compare with construction, you will like to do construction because you want life to take rest. Right? Right. If you want to use your design caliber, you must go for EPC. If you have that caliber, because there you have opportunity to design yourself, to scrutinize yourself, to review yourself, and to procure yourself, and to construct yourself. Your that authority, you not 100% to do, but you can have, involve yourself in every act. Generally, you do not get this opportunity in one world. Everybody is, it is. Some people I have seen in my career on EPC that there is no company that can continue independently, and that's true. So generally 3 or 4 or minimum 2 or 3 companies before doing bid do constitute alliance, or you can say JVs, joint ventures. Joint ventures or alliances, same thing, no difference. Joint ventures are those where one person knows design, other person does not design but knows how to do it. So these 2 or more, we say 2 only. We don't know. Running is very important on such projects. Your technical knowledge is very important on such projects. Your device specification and your device drawings and your performance requirement of equipment, because you have to involve technology and that company who gave you technology, they know what type of instruments or equipment are required, because they have done that type of job within that organization, and they move like this. Your mind, we are learning and for this machine, and you cannot make any answers. Well, I'm getting a little sway just to explain to you before jumping on the conditions, because conditions must be based on what you are thinking. In this case, design starts with surveys. You know this, I explained before also. First, land you can't change if it's allotted, and maybe you have to make up that land in many cases, because these projects are located certain near sea area, and there you don't think that there's some existing ground or something there. Maybe, may not be. If some other projects are there, could be. But generally, you don't find any habitation there, any, you can say, residential area there, or any commercial area there. This such areas are free from everything. That's also true. In that case, what you have to do, you are given land plot, you have formed, you have seen that when you started this machine, yes. These designers who have to design, what is their job first of all? First job is, even though there is some soil report available, you cannot go through that soil report. Forget. You have a plan now. You have a plan at least which vessel is located where are trains coming in, where is process area, and where are other areas, warehouse, administration, or electrical stations, like that, to have some plan ready with you. And that plan maybe have taken approvals from client. Alright, that's fine. This means you have to certainly redo your, say, geotechnical survey, geographical survey for that area, though no raise of ground has been done, which may be done later on. But whatever is existing, you have to understand what is existing. So now it's up to you how to call laboratory people or reach them and confirm with them what do you want, actually what's your requirement. And then laboratory shall certainly, after due negotiations, allow you balance that problem. When you do soil investigation, you have to mark where board is required, where you want plate load bearing test, or where you want something else, and how many you want. You have to do everything in laboratory now. You may conduct 50 loads, 100 loads, boards, particularly where loads are available. When you get this information to laboratory would start their work. They may take maybe 2 weeks, 3 weeks, it doesn't matter, because they are not going to do anything now on this. But you have to order machines. You may get some information within few days of something, that what soil is there or something like that. Just like you move on materials after decision, you cannot move on design immediately. This design also, if you deliver immediately without any feedback or without any input from manufacturer, this will be hoax design. And problem would be on site that they may start carrying that, though they are not working yet, but you have to be very careful. You have to find out parameters and locate those machines in that area you have taken up, and you can also send those to your people just for information, not for construction. Information is okay, that's fine. You can give for information that this is not construction, not at all for construction, this is only for that. This is what I say to all those who are related in such dealings, and all designers. Yes, they have to continue the design secretly, confidentially. They have to work on that with many possibilities. And when you decide, or your other engineers, or your technologists, or your those who are giving you licenses, that's technocrats, if they give you according to requirements, these are data of machine required. That machine we access machine factory. You pay them. First part of your game is ongoing, and you are supervising that circuit. You are doing also electrical resistivity, thermal resistivity, or you can say many other tests, as I said, plate bearing test, bore logs, and whatever else is required, keeping in view what material you are going to install on that project. Soil resistivity, thermal resistivity, electrical resistivity are very important part. You may have to excavate deep foundations also. You may have to keep water bodies also. So all those points you have to keep doing. And this may be full range test, or this may be part test depending on requirements. So soil investigation is a, you can say, full job there, big item, and then also You have to fill area, certainly. Maybe generally it is raised because billions of millions and billions of machines are there. Generally this is sea, and there are chances water may come in during a calamity. So what happens? Raise of level is done. Once survey sector is done, we have to raise levels maybe by 1 meter, 2 meter, or maybe more. Those filling levels, which you can say, those levels may be called site preparation in some case. Maybe you can say it's a kind of site preparation. Whatever site is available that is not well prepared, that's not means some sites are there which are nearly same as we have to do to start job with. There's no requirement of site preparation in those cases, except cleaning and clearing all that. But there are certain sites which are required to be raised from that level for many reasons, and machines and almost 2 meters or 3 meters upwards. It's important in some cases. Just like there was one, that was not from this reason. I saw one artificial mountain city in Doha, Qatar. I exactly forgot the name of that area. And once you go to that artificial city, you had to cross. You are going to Alco Road. Well, there's a city, and it was raised by many meters. We also were involved there for some substation construction in those areas. So I remember. So same way I was involved with one ethylene plant in some area, and we raised that, we filled that layer, and millions of cubic meter material was filled. There's millions of cubic meter, and you see if you fill that much, how many layers must have been filled, and what type of materials might have imported for that, because we had to do. And how could we design that material mixing, because such graded material is not available anywhere on any borrow pits. So you may have 2 or 3 materials combinations, so that after combining these in different ratios, you may reach certain ratio proportion or division of those particles, the varying sizes, grains, so that you can reach a single graded result of graded material of meeting your requirement from 2 or 3 materials mixing in various proportion, which already we had talked of in some case, how to mix up, how to experiment, or how to test that, how to design that different material mixing using certain curves. Recently I talked about that. Of course I also learned that something. And that material is not same uniform, you can say, because it is millions of cubic meter. You may have to change source also. Maybe you can't get that metal from one source, or you may have to import also from far distance. In that case, you have to continue keep busy your metal testing laboratory to find or keep a watch on when there is a change in source, in mix again, and that's very big technology, you can say. And you have to test also about compaction on site, what compaction is required for this, how it is required, how many passes are required for that. It's all part of site preparations. You have to actually create some site for that, and you have to see whether you use your ruler on that big page. It's not a laboratory one. You have to use this on site, selecting long area and filling in depths of whatever, say 200 mm to bring it down to 150 mm, and as usual keep it wet and then compact it in, and test it. This is how many passes are required. Every time you change material, or in between also intermittently you ensure if this many passes. Then you have to either find bearing capacity or field density of that. Field density of that. And one way, site preparation is on, and other way soil testing is on. And this also soil is a mixed design for purpose of backfill, for purpose of site preparation of and that is up to 95 to 98%. In some areas maybe 98%. I don't think this is process area or load bearing area, and there will be certain areas there no structurals are there, just fields are there, landscape or roads are there, that can be 95%. Just depending on, you can say 98% field dry density. It's this way that site preparation goes on, and it takes a couple of months also to do that site preparation for that purpose. That's very important. Site preparation is very important in such area. You have to bring site to a level where you can start working for construction. And if you do not do that, it's not building work there. Just you say you can't raise levels of this building. There's a restriction. You can't take more than 45 centimeters from road level. In some there are bylaws, but here bylaws do not apply. You have to see site. Municipality don't come into play, or departments or authorities do not come into play. These big projects have different rules, and you have to keep water ingress safe, because whole sites, and particularly those areas chances of flooding are imminent. Those shall be barricaded by some wall, and all levels are raised because of that reason. And if you raise 3 meters, say, it's not a big issue on such projects. If we can, yes, if you say, first time we complete all areas, that's fine. First time, second time, third time, or fourth time. Even fine, that's very important point. Site preparation, on the site preparation is very important point, and it also allows you to find route. Well, the site preparation, a long activity, and once you know electrical resistance of soil, electrical conductance of soil, and also thermal resistance, and many more properties of soil, including bearing capacity, including bore logs, means what says bore log, it has to tell you, maybe you've got 20 meters deep, you will find results. And then it's a big job for you to understand that, because site preparation doesn't mean you have prepared site for foundation. Again, you have to excavate, same as usual, considering all of that this new prepared site is the original one, and you have to excavate where it's required. That's the important point. Excavation, again you have to do it after filling, and you have to go more than that wherever required. Soil report, soil investigation will tell you what you have to do, and you have to use in such facilities big cables, many cables, and duct banks, and enormous services you have to put in there in such projects, services, and you have to connect all your buildings, companies, Then you can say, what we do next? We have to find. Next is nothing. Just we have to prepare ourselves. It is not simply site preparation you have done. You have to make access road also from highways, which is also big job. Maybe highway 3 kilometers off, 4 kilometers off. You can't say 1 kilometer off. There's nothing. You are starting that side. So you have to make some road on way. There may be some drains in between. There may be some other items there which will barricade your work. What to do? You have to establish a road. And that road should not be an ordinary road. Because you have to bring in heavy duty trucks for construction. You have to bring in heavy duty equipment. You have to bring in everything. So that should be that much. And also if required, you have to construct a nursing center, nursing home around for community who are staying there, and this could be a part of your contract. Lot of work is to be done. That's all I can say. You have to provide access road, and they have to surveys and all that, and you have to provide camping for your people. That's called mobilization. Camping for your people. Thousands of workers, hundreds of staff of your organization, and of organizations of subcontractors or other companies, and other consultants coming to site, and client. You have to provide all facilities. It's a kind of residence for few years, because they will stay for few years, depending on what, maybe 2 years, maybe 3 years, maybe 4 years, maybe 5 years, 6 years, depending how many are there for 4 years, how many are there for 3 years, 5 years. You have to plan it out, schedule it out, and you have to apply for where you can do that. If your owner is not in a position legally to give you, then you have to go to relevant authorities to get that and allot it to you. That you have to done. You have to have done. You have done it. Means your job is a very important job. So you have to construct that camp, and you have to construct. Something mobilization of all that you have to do. Mobilization from total mobilization for execution. Mobilization of site, mobilization of offices, mobilization of consulting offices, mobilization of the client offices, mobilization of subcontractor offices, mobilization of your offices, mobilization of staff offices, and eating and all arrangements, because this is the desert is required. And meanwhile, it will be a few months. You can say it shall be a few months. By that time, this few months time will be for you to design, to consider that, and then start doing something else. If you don't have at least machines ready for you, you don't have information of designs of machine or which machines you are going to buy, but at least buildings are not a big problem. Buildings where there is no machines in, I'm not talking buildings where machines are, talking about machines. Other buildings which have nothing to do with process plant, independent of that, just serving that, like administrative building, like warehouse building, like other laid down areas, and like you can say central control building or substation building, which are in a position to be designed and erected, whose designs and erection can be started. You can say structural still of those warehouses where those houses where building these machines are going to be in. Structural still is also not a problem. That's normal one. May only you have to design and you have to place in order. Only problem is where machines or equipment are there. you don't know exact capacity of those machines. You have to depend on that. Maybe it takes few months to decide, or few couple of weeks to decide, and you have to place order for so many watts. I'm just trying to tell, this is not procedure I'm telling you. I'm telling you how to use time, because project you have and you can save time only like this. You cannot leave to, oh, we'll take next one, we'll take this in next one, then take that. No, you can't take. This is serious matters. You should understand priority of what is there. That priority is that you have to open many friends for site, many friends means many members of your video. When this happens, means you can say that now we have approximately mobilized. Yes, you have mobilized only on the accommodation. Meanwhile, you have also to arrange personnel, all level personnel, which also take time, space of an overseas country where you are not having the staff. And you have to arrange with ministries also how to get these people. This is staff, these workers from this country, that country, because there may be some legal restrictions or legal requirement that there is a percentage of people from this area of our world, there's percentage of people from this area of our world. From that point you have to keep in mind. You cannot go oppose that. You have to accept that. You have to accept that liability. Right? Maybe 10% from this, 10% there are so many Westerns, so many Americans, so many Asians, so many. That point also you have to. This is all very undeclared practical. You cannot say this is a part of something. This you have to do it. It is important one. And then you have to you have to make some office, your office, site office, or your some other office somewhere. You need that. In that way you can say. Your EPC lanes means conditions of EPC designed based on all such activities. These activities are not normal; these are abnormal, and these relate to each and every part of contract. And you then study your drawings. Just to design coming does not mean you are ready. You have to study designs and study at least designs have started coming in. In that period, maybe you get half sets of drawings, not all. And then these things keep on coming all the time. And you must have a coordination office in your somewhere. Coordination if you are a subcontractor or you are a contractor, depending upon. Coordination means you have to coordinate with many people, you have to coordinate with drawings, all drawings, not one discipline, all discipline drawings. It's not that small is you are not only to the architectural drawings, structural drawings, services drawings, other drawings, and all relevant specifications, all. And you have to elect your subcontractors also. You have to elect or nominate your various subcontractors. If you have your own division, you have to work with that division. That's another important point. Means so much is there. I will take all this later on. I'm just trying to include in this talk because I want to discuss on contract conditions. And if I will discuss on EPC contract conditions, we should know first of all. Because every time if I explain something is relevant to that item, it doesn't mean anything for you because you are at different position. You may not be clear what I'm talking about, and if once I make it clear, means what does it mean, how this condition, when I talk to you, I will relate that condition to what we are talking about. I'm talking now, I'm just trying to tell you how to start a job, how to start a job for execution purpose, execution of overall job which is estimating to billions of dollars or billions of rupees or whatever, which is not a small amount but considerable amount, and that point must be kept in view while doing all that. And if you don't keep that in mind, you will certainly be in a problem. You cannot go haphazardly. Every proposal, every you can say action that is an important one, every direction that is an important one must be charted somewhere. Must be charted, you can say, in charter of site or project. As we discussed in programming, charter, project charter. You may give whatever name, but I say it's project charter, in which is defined all activities. So wherever you record, I'm not suggesting you record in planning, no need. Record whenever you want to record this charter, but in industry. They say it's not easy, just like I said, design point of view considering in these conditions. Design is very big. Similarly, we consider other points, selection of personnel and facilitating personnel, say engineer's office required, our office is required. All those are here. All camping facilities and site facilities are required. Entry gates are required, and fencing is required, and you can say controls are required. So much is required, and access road, which is very important part. And depending upon what site is, everything that you require, and you may have to go somewhere else also, or something else. So it makes everything very complicated. So my dear friend, in this talk, what we are saying, we have here design condition, that is phi 1, and then general design obligation, and then there is after that contractors documents, we have discussed some, we'll discuss also, and then there are after that will be contractors undertaking. This all we are talking is contractors, some kind of undertaking we'll discuss. Then technical standard and regulations is are there. And then training is very important part everywhere. Our people, others people. Training is integral part. And then as-built records. Here, because there is no service, if there is service, you need records. You need records from those operators who operate in that area. You may not need to go to municipality or some other areas, because this is operators areas facility. Whoever refinery is there or someone else is there, they can provide you all these records. Operators can provide you these records, and then operation and maintenance and manuals, and all these are different process, design errors. Means let us say this design errors meanwhile just for observation purpose. I'm not just for purpose. If errors, omissions, ambiguities, inconsistencies, inadequacies, or other defects are found in contractors' The contract is designed and a contractor's documents, they and what shall be corrected in accordance with subclause 7.5 defects and rejection. Such contractors' documents were previously subject of a notice of no objection given for being marked. Whereas subject of notice of no objection given for be given by employer under subclause 522. Review by employer, no prejudice of clause 522 shall apply as if employer had given a notice of respect of contractor's documents. It's part one. I'm nearly going to close now. That's I think a couple of minutes. Let's say there are conditions so far in this, and we have covered how many conditions. That's point here. We have covered conditions. Now this is now there's with staff and labor after that. So let us see how much we have covered so far in this, and we may just so far we have said that we have covered in this. This we have covered. That's contents as usual are let's say contents as clause to 1 to 21, Then appendix is general conditions of dispute, avoidance and adjudication. Agreement, annex, DAP is all content. And contents are introductory guidance notice, and I'm going to contents, not this one. This one is sometimes if acknowledgement is there, nothing to do with acknowledgement. There are some diagrams here. These diagrams are for, one is for typical sequence of principal events during contracts for EPC turnkey projects, and then there is the typical sequences of payments, events envisaged in class 14, and then there is total sequence of disputes, events envisaged in class 21, then typical sequence of events in agreement or determination under subclass 3.5, scenario 1, scenario 2, scenario 3, and after that is FIDIC conditions start in that, and this say that it is clause 1, general provisions in which we have studied definitions, interpretations, notices and other communications, law and language, priority of documents, contract agreement, assignment, care and supply of documents, employers' use of contractors' documents, contractors' use of employers' document, confidentiality, compliance with laws, joint and several liability, limitation of liability, contract termination, and employer, second clause, right of access to site, assistance, employers' personal and other contractors, employers' financial arrangements, site data and items of reference, and then employers' supplied materials and employers' equipment. And third is, that is clause 3, employers' administration, employers' representative, other employers' personal, delegated persons, instructions, agreement or determination meetings. Fourth is contractors' general obligations, performance security, contractors' representative, subcontractors, nominated subcontractors, co-operations, setting out health and safety obligations, quality management, and completions by evaluation. Then it is nominated subcontractors, and then cooperation, setting out health and safety obligations, quality management and compliance, verification systems, use of site data, sufficiency of contract price, unforeseeable difficulties, right of way and facilities, avoidance of interface and access routes, transport of goods, contractors' equipment, protection of environment, temporary utilities, and treasurer's reports. In that case, I can say avoidance of interface, access routes, transport of goods, contracts, equipment, protection of environment, temporary utilities, progress reports, security of site, contractors' operation on site, archaeological and geological findings. And then you can say security of site and contractors' operation at site and archaeological and geological findings and design, general design obligations we have to study. Contractors' documents we have to study. Contractors' undertaking we have to study. Technical standards and we have to study. As we have to study operations and design errors, staff, etc. which we are talking of. Only this we have covered so far. We shall cover all. There are 20 clauses in that. It's not construction, it's EPC, so there's some variations, some differences. We have to understand those in whatever case we have to do. EPC, as I said, this is engineering, procurement, construction, and we should say construction is also engineering, procurement is also engineering. We cannot say only design is engineering. As always I said, more quality conscious we should be in EPC, because it is total responsibility. We cannot pass responsibility to engineer or to someone that this person is responsible. He provided, you can say, inaccurate design to us. This you can say, this safety cover is not available in APC. Even if it is right or wrong design, this is your baby. You have to ensure it's sufficient. It suffices or it doesn't suffice. It works or it does not work. It's your responsibility, no one's else's responsibility. This is grave point in EPC. If you have to work like, if you are going to if you are going to learn from EPC, and you have to be strong in every act. because your act, it's not consultant's act. There's no consultant here, no consultant. You are consultant here, you are constructor here, you are designer here. Employer's representative is not responsible for this. So that will be for employer's satisfaction and not for your satisfaction. Employer may pay or may not pay, it depends on the employer. Remember, whatever you do in EPC, remember it's your liability. Even if you're a subcontractor, it's your liability. You may say design, a subcontractor has a chance. But I have seen that main contractor or designer gets an undertaking in subcontract that work, if required to be reworked, you will not be paid anything, you have to do that. And I think rates are reasonable there. So I think 5% maximum, 2 to 5% works are done again or modified. So that can be digested. That's not a big deal because it's foundations only. In buildings, it's not redone only in foundations. I'm saying it may be strip beam foundation or maybe isolated footing, or maybe it's a block foundation or massive block. There can be some variations possible of reinforcement, not in size, dimension, or in fact. So that type can be taken care of, but you cannot escape. And once one work you do it, then you won't find any problem. Or you work to one work, or you be a part of subcontracting. You can also learn a lot. Subcontract is not only the subcontract; it's a full-fledged contractor. Subcontractor for civil works, you may say. Some companies have power for mechanical, electrical services, but they don't have capacity building available for civil. So what they do, they sublet, they subcontract civil items, civil works to others who are civil experts. They have all managed staff, proper professional staff, and such type of workers with them. So they are happy in civil contracts because this is not small amount, this is a big amount, and this for 3 or 4 years. Everybody is big in civil side, defense, sales person will sit here in the time. They follow the advice of sales thing. But it happens. Civil works is a very big element. I remember on one project, even total concrete cost more than 100,000. It was about maybe 150,000 to 200,000 cubic meters, including massive foundations and water was there. When this happens, you have to be master of your thinking. And again I say, as I said in the beginning of talk about engineering, it is same, I repeat, think and deliver. Think and deliver is a long distance travel, remember. It's not simply like same thing, take off flight and landing. So take off is big thing, it's not take off, you have to take off, that's one part of that, but think, boarding is thinking, ticketing is thinking, security check is thinking, customs are thinking, immigration is thinking, big responsibility. Only intelligent, brilliant can think, or those who experience can foresee Thinking is nothing but force here. You're not researching here, you're not doing atomic research, you're not doing electron size, you're not. This means you see what can happen. That is vision, visionary thinking, calculated thinking, design based thinking, results based thinking. All those thinking should come into your mind without any problem. And then you receive something or reject something, that's up to you. And that must be shared by all people on site. Share. That point counts a lot. I just wanted to deliver you all this because this is very important, and I say that if we can't do this, you shall become failure simply. You may not stay in that status if you are employee or officer or big engineer, because after all you apply your mind. Application of mind is more important than running here and there. Concentration, I would say, from beginning till end. Concentration in designs and concentration in procurement, as well as concentration in working on site. Concentration in analyzing all details, concentration in coordination, concentration in communication, concentration in researching, and concentration on getting clashes from site and then resolving them. It's that sequence. If you are 2 or 3 or 4 people or persons, do it. I think you will be fit everywhere on that site, and that site shall stay on tips of yours. That is where it works, and I understand. It's not difficult. I'm just not discouraging you, but I'm just trying to elevate your knowledge. If you think that way, then you should be thorough in study, not pass study, but learn study after college, after university, after living. Don't stop study. Stop your textbooks, but learn resources, learn works. Go and learn everything. Learn statements which are how to do job, how to do work, methods. That's very important in engineering. Without writing method, you cannot be allowed to work, because it's time, cost and quality. Nobody shall allow you to spoil material, and even your supervisors shall not work if your people sleeps. You cannot say, you will get up and you will do that. You have to suffer. And on top of that, empowering your concentration, empowering your advancement, empowering your knowledge, planning, scheduling, reporting, meetings, coordinations, noting, specifications, reviewing, and writings, and transmission of information to site. Very important one. Your document controller should be master one. Your site engineer should be master one. Your foreman should be support of site. They should lead works. They should not sit. Don't even give them drawings. And if they understand, you can give them drawings also. And your RCC work, bar bending, scheduling, and concreting, and all that. If all these sequences, form works, and you understand once, and you project your methods in a professional way, EPC is successful. It shall be successful. And once it is successful, you enjoy. What's the problem? And you can say, I can do EPC And if you can do ETC, you will get jobs and jobs and jobs in high profile companies, not in low profile companies. But you have to learn. This management is different. It's not business management, it is technical management, specification management, drawings management, and all documents management, big management. This management continues for years, not for few weeks or few months. Somebody comes to your site and says control something knob on your wall. Yeah, hello, I'm control. It's not air conditioning like that. Here is your valve, here is your knob, here your dimmer. Everything is here. You have to use the switch panel. You can say this is your switch panel, or this is your SMB, or you can say whatever you can say. You have to depend on this. If you want to move in EPC, I will not take much time now because it's already more than 5 hours. I would like to say, I hope you shall get better idea from my small discussion of few hours. Maybe I was little inconvenient today because I could not get some files correctly, and I'll try to use them again so that everything should be clear. That's why I'm a little uneasy due to something. No problem, it happens sometimes. Because of Facebook also, it's not very well today, it was not well yesterday. I could not load those documents on video. I'll try to do it again. And again, I say thank you once again. I go to YouTube first and close that. First of all, I close YouTube and thank you YouTube for this video. It's okay. I close this and stream and then I close Facebook here. Thank you Facebook, you too. And both are closed.